Hey, what's up and how's it going? My name is Toby, and in today's video we are going to build a prototype for an AR multiplayer experience. Better said, a 1 versus 1 arcade shooter experience that is going to work crossplay in between iOS and Android devices. So my goal with this video is to show you guys the basics of creating a multiplayer shared AR application so that you can go ahead and just realize whatever shared AR idea you have. For that, we are going to use the Unity engine as well as the free plugin Lightship, which is going to allow us to create such nice shared AR experiences that are actually cross-platform. So this video is supposed to be beginner friendly, but of course it's a huge advantage if you already have some basic knowledge about Unity, and I would highly recommend that. And it's a solid plus if you already have some experience with Unity's netcode for game objects, which we're going to use in this video. So we'll begin by creating the experience in standard 3D, and then we'll implement a way so that we can very easily switch between standard 3D and AR, so that we as a developer have easier experience just creating this app. So for our multiplayer, we are going to use image tracking for colocalization. And by standard in Lightship, you will have to predefine an image, but we are going to find a way on how to dynamically set it so that, well, the players can just play and create a new shared AR session anywhere they are. And it's important to note that all the tools and plugins we are using for this video are completely free, so you don't have to spend any money. And all the important information and scripts and everything we are going to use is in the video description, so please take a look at that first. Alright, so without any further ado, let's get started. It's going to be exciting. Okay, so of course we need to start by creating a new project. So I got my Unity Hub open here. I'm just gonna click on New Project, and I'm using the editor version 2022.3.11, which is the LTS version for 2022. And so I'm just gonna choose the standard 3D Corp project. I'm gonna choose a location, and I'm also gonna change the project name to shared AR tutorial. All right. So let's select the organization and just create the new project. And once the project is open, we're gonna install Lightship next. So this is quite easy. We just need to go to lightship.dev, and then we can go to learn, and then we can say getting started. And here we have a pretty quick and easy guide how to install Lightship. So pretty much all we need to do is first of all copy this link here. Just copy, go back to Unity, and then we can go to our package manager, and we can click plus, add a package from Git URL, and then we're just gonna paste the standard ARDK package here and just gonna add. And it's also gonna initialize the new input system from Unity, so it will need to restart, and it will take a little bit to install this package. So I'll be back in a second. By the way, the version we're using here is Lightship 3.3, and depending on when you're watching this video, I would highly recommend you guys to use a similar version so that everything for you will be the same as for me. Okay, so once this initialization has finished, we see an error message here which says that we need to provide a Lightship API key. We are going to do that later, but first of all, we also need to install the Lightship Shared AR, so the multiplayer package. For that, we can simply go back to the documentation here, and we can simply copy this link here and do the same thing as before. And here we are also using 3.3, and this is also quite important because it will auto install the netcode for game objects, which is Unity's proprietary a multiplayer solution in version, I think it's 1.6, but of course it's not the most current version. And if you're using maybe a later iteration of Lightship, then you might get a later version of the netcode for GameObject, and so things will maybe change up. Okay, so next up we wanna get our API key so we can actually use Lightship to a full extent. So for that we can just either sign in or create an account at lightship.dev. Okay, so after that you will be on the dashboard and you can simply click on projects, create a new project. We can call this one shared AR and then just copy the API key to your clipboard. So back in Unity, we can go to Lightship and then to settings. Here we can simply paste the API key. And then we can also go into our XR plugin management and select Lightship as a provider for any platform that we want to use. So for the PC, of course, for testing reasons, then on Android and on iOS too. You can already see that there's some kind of issue here, and this is because, of course, we need to switch our build platform. Right now it's still on PC. For that we can go to File, Build Settings, and then we can simply select the platform that we want. So in my case it's iOS. By the way, if these are grayed out, then you'll need to add these packages to your Unity install. For example, you can go to your Unity Hub installs and then you can just click on Add Modules, and then you want to add the one that you want to use. Okay, so we can just choose iOS here and just switch the platform. And we can already add our open scene to the build settings, because otherwise, well, if we build the project, nothing is going to happen. All right, so let's go back to Lightship and settings. Let's check the project validation here. And in the project validation, we can still see that there are some settings that need to be tweaked. But we can simply click on Fix All. And once all the error messages are gone, we are good to go with our AR app. Again, a little heads up. So Lightship version 3.3 is using version 1.6 of netcode for GameObject, so the Unity multiplayer package. It's not using the most recent, which at the time of this video is 1.8. So if you're used to work with 1.8, some things, well, are a bit different. So again, I highly recommend to use the same versions as I do. So in order to test our multiplayer game, we will need to install Parallel Sync as well, which is a little handy tool that will allow us to just test multiplayer on our computer, so we don't have to do a build every time that we need to test out if things are working. So for that, check out the link in the video description and simply download the Parallel Sync package. Here it's version 1.5.2. Once this is finished, simply go to Assets, Import Package, Custom Package, and then just simply click on the package and on Open. We want to import everything. And now we should see in our top bar Parallel Sync and the Clones Manager. And in theory, we could now create a new clone of our project, which would allow us to simulate some kind of client or second player that can join the game, or we can even be the host on the clone. But we are going to do this later on. Okay, now we're all set up and can start creating our experience. So to make testing and developing our AR app a lot easier, we're going to first of all build everything as just a standard 3D application, and we're going to add an AR toggle basically later on, which allows us to very easily switch between a non-AR and an AR application. And this is going to make everything a lot better and the whole developing experience a lot easier. So let's first of all start by renaming our scene. So let's go here into our project settings, scenes, and let's just call this game. And here we are going to simply add a few components. So for example, let's create a plane that is going to be our ground. And we are also going to create a new UI canvas, which is also going to add an event system, and let's call this UI. In the event system, we also want to replace it with the new input system, like this. Okay, perfect. Next, let's move the plane a little bit so we can just set these scenes next to each other, so the scene and the game, and just, for example, move this a bit towards the camera like that. Awesome. Yeah, I think that should be enough. And maybe just take this camera and just move it a bit down like this, so we have some kind of top view. We can just switch to this landscape mode here so we can also see a little bit better. Perfect. So let's unify this. So then let's create a new empty object and call this Network Manager. And we can add a component, Network Manager, like this. And so for the transport layer, we are simply going to select Unity Transport, not yet Lightship. This is something we're going to do later when we want to switch between AR and non-AR. All right. So before we're gonna go further, let's just test if everything works in theory. So for that, let's just click on Parallel Sync Clones Manager and create a new clone. By the way, these clones usually work quite well, but sometimes if you switch a lot and you change a lot of settings and maybe add packages later on, they will get some kind of weird error message. So at some point, if you get many error messages on your clone and things are not going so well, just delete the clone you have here and create a new one rather than just trying to mess around with the settings. All right, so let's open the clone in the new editor. And also make sure to set the log level to developer so we can just clearly see in our console here what's happening. The deeper this level is, from nothing error normal to developer, the more messages we will receive showing us whether what we're doing actually works. It can take quite some time until the clone is open, but now it actually is, so don't worry about that if it takes a bit longer on your side. So let's just open the same scene here. And one important thing, do not change anything on the clone because it's not able to save. So every changes we do, we're going to do in our standard scene, but not in the clone. This is very important. You just get some error messages and it's not too bad, but still I wouldn't necessarily recommend it. So then in order to check out if things are actually working, let's just click on our network manager here and let's just click play. And we can also click on the network manager here. If there's a pop-up that things have changed, just click on reload and also click play. So here in our left scene, can just open the don't destroy unload. And here's network manager and we can just start host. So we can see, okay, it started as a host and it initialized. And here we can click start client and yep, a client connected. So overall, the very basic functionality of the network manager works. Also here we can see that we are connected. Perfect. So now we can start creating our game logic. The first functionality we want to build is placing down an object. And for that, we first of all need an object. And so this is going to be what our player looks like. I found this asset here in the Unity Asset Store, which is completely free. The link is in the video description. And you can just log in here and then add it to your Unity assets. Back in Unity, we can go to our package manager, which is under window and then package manager. And here we can go to our assets and search for this Battle Royale duo. And so let's simply import it into our project, and then we can use it as our player prefab. So once it's installed, we should see it somewhere in the assets. By the way, you can of course take any kind of asset you like, but we're going to use this one in our video. Then let's create an empty game object and just call this player, or maybe player one, like this. And we're going to take the prefab here, so we can, for example, take either the male or the female PBR. So in the first game I built for this video, I took the male, so let's take now the female one and just drag it in the player. Can click Shift F to zoom. Let's make sure that also the player is resetted from the position and rotation. And so this one is also just at 0, 0 in the transform values. Otherwise we would have to just reset this as well, like that, but it's doing well. Awesome. So we now got our player, and let's just prefab this one by creating a new folder here and call this one, let's call this one player, and just create a new prefab like this. Perfect. So in order to edit everything and keep it in our prefab, just open this one up here, and we need to add a few components. So the first one is a network object. So network object like this. And so this one is going to just make this object replicatable. So that means that it can be spawned, for example, on the host, and then it can be also replicated on the client. And of course, as we are also moving this object, we need to add another component, which is the network transform. It will transfer the movement values, so for example, the position, the rotation, and the scale from one player to another. The issue is that the network transform by default is server authoritative, which means that if, for example, the client wants to move forward a few inches, then it needs to send a request to the server, and the server needs to say, hey, okay, then your request is valid and we're going to move the character forward. And this can make sense for any kind of competitive shooter or any kind of multiplayer game that is very competitive and you don't want people to cheat. But in augmented reality, we're dealing with limited resources and we don't really want the one phone to handle all of the decision making and moving objects. We want to spread out the tasks as evenly as possible. And it's also not such an issue that you would potentially cheat, especially if it's more of a arcade game or a more cooperative game. But in the future, maybe, well, when phones get more powerful, then we can, and there's some kind of competitive AR game, then we might want to do a standard server authoritative one. In order to not make this server authoritative, we can go to the Unity documentation, and of course, there will also be a link in the video description. You can just scroll down, and there's an example of a client authoritative, addition, which will basically just inherit from the standard network transform and will simply override whether this is server authoritative. And all we can do is just copy and then go back to Unity. And let's create a new folder and call it scripts. Scripts. Like this. And then we can create another folder that we want to call networking, for example. And then we can create a script and we want to call this client of network transform, let's say. Double click this one and open it in our code editor. And in the editor, let's just delete all of this and insert a code. So let's just let's just quickly copy this one up to our class and remove the class and namespace and everything up here. And we of course need to inherit now from network transform, like this. Awesome. So let's also just remove this comment. Let's make it clear and easy. And I think there's one bracket too much. Perfect. Shift tab to just reduce the spacing here. All right. Awesome. So what does it say here? Okay, something with the namespace. We will not care about that right now. It's not a big issue. So in our Unity editor, let's just quickly grab this one and add it to our player. Okay, we already got this one on here. Let's remove it and add this one. And so now it looks exactly the same, but the client is able to move their character by their own free will, basically. And we don't need to sync all the values, so we will not work with scale. But yeah, position and rotation will be important. And well, if you want to implement jumping, for example, later on, then also, of course, the Z position, the Y position would be needed. And we're just going to leave it like this for now. So in order to keep track of all the network objects that can be used across any player, we need to create a new network object list. So for that, let's just go to our assets, create a new folder. So we want to keep everything nice and tidy. So let's call this network objects list. And create a new network prefabs list. Okay, so doesn't matter what it's called, it's going to do the same. And here we can just click on the plus and just drag in our player. And then in our network manager, we need to also drag in the network prefabs list. So let's just click and drag like this. By the way, you see that there's a player prefab selection here. And usually you would take this one if you, for example, have a clear character that you control, like we do, for example. In a strategy game, let's say, where you are not just a single character, you wouldn't need that one. The reason why we are not doing this is, well, because I want to show you the approach that will not involve the player prefab, because I know that many AR games do not necessarily need a single player, and so we will just do the different approach. So in case you maybe want to create some kind of strategy or some kind of different game where you do not control a character, you also know how this approach will work. Alright, so next up we're gonna learn how to actually place down a character onto our mesh, and for that we can go ahead and delete our character from the scene. We won't need it any longer. And we're gonna create a little new script. So we can go to our scripts, create a new folder, let's say, and call this placement. And create a new script, and we can call this one, let's say, place character. Let's double click. And from one of the prior tutorials, I already created some kind of placement script. So we're just gonna use this one and we're gonna modify it to work in multiplayer. So as always, the script is in the video description. And so we can simply copy and paste. And I'm only gonna copy and paste the inner code here. Like this. And of course we then will need to import a few things. So I can just click on a few buttons here to just import all the missing dependencies. So it's the event system and simply just here the Unity engine. And yeah, so that should be good. And then we of course need to modify the script so it will work for multiplayer. And for that, we can begin by just inheriting from network behavior instead of mono behavior, which is going to add all the methods and all the information that Unity's netcode brings. So first of all, let's begin by deleting the placed objects list. Up here, we won't need this any longer. Down here, we're not gonna add it to our placed objects list, but we're still gonna instantiate it. And we're gonna create a game object here, and we're gonna call it the character. And then next up, we need to get the network object of the character. So character network object, let's say. And so we're going to take the character.getComponent and we're going to get the network object like this. And since this instantiation here is only locally, so only the player who's going to click and then instantiate will see the character, we need to also spawn basically the network object, which is going to send a signal to the network manager and who's going to then spawn the object on each client. So let's go to our character network object and say spawn with ownership. And this is quite important. So we are, we are not going to just spawn the object, but we also want a specific player to own it and to control it. And for that, we will need the client ID. And this is what we are going to pretty much do next. So up here in our method, let's just quickly create a new unsigned long. And we're gonna call this local client ID. And this is going to be the network manager dot singleton and the local client ID. All this does is finding out which ID our device has, and then we will pass this into the spawn with ownership. So that means that if our local player clicks, object is going to be instantiated on the local machine, and then it's going to spawn this one for every other client so anyone can see our character, but we still have the ownership over it, because otherwise if we are going to attach the control script later on, which is going to move the character, let's say by moving our thumb up and down, if other clients would do that, they would also be able to move that character, and of course we don't want that. However, if we would now run the script like this, we would get an error message because clients cannot spawn network objects, only servers can do. So what we need to do is we need to create another method, which is going to be a so-called server RPC. And this means that a client basically calls the server to do something, and then the server decides whether, it wants to do it. But in our case, as we do not do any checks, which would be normal for a server authoritative game, we're just gonna basically spawn. All right, so let's call this one spawn player server RPC. It's very important that we have the server RPC at the ending of the function, because otherwise we'll also get an error message. And we also, need to set a little flag here like this. I'm gonna call this server RPC, and we say require ownership false. And this means that basically any client can call this method. And we will of course need, the position and also the rotation and the local, let's call this caller ID, because this is the local client. He's going to call this to the server, and this method is only going to run on the server. So basically, all of this code we have here is going to go into our new method. So let's just quickly, let's delete both of these things here and just cut it out and move it into here. And instead of the hit point, we're going to take the position. Well, we can, first of all, let's quickly call this method here. And it's going to take the hit point, the hit normal, and then of course our local caller ID. So let's, well, first of all, take this, then this one, hit point, hit normal, and then let's simply take the local client ID here in the method. If we would call this on the server, by the way, we would get the ID of the server. So this wouldn't be the right one. Oh, and I think we'll still need to convert the hit normal to a quaternion, of course. Let's just quickly create a quaternion like this. So quaternion, I'm gonna say from to rotation, and we can just say vector 3. Just gonna take the up vector. I'm gonna take the hit normal. All right, so then let's just put that into our function here, like this. And now, well, we can instantiate the object onto the position and the rotation. So we can do that on the server too. Okay, I already had this one here, but this way it's cleaner. And of course we can spawn with ownership of the caller ID. We don't need this anymore. All right, awesome. So let's just try out if this is already working. So of course for that we need to create a new game object, and let's call this one just place object or place player, just placing the player, and just drag it here. And well, of course we need to get our main camera, and for that we'll also just quickly change the script. So we want to say that, for example, on or maybe just gonna say start, we're going to set the main camera just to game object, game object find object of type camera. And we're going to do this because we will later on switch between AR and between just a normal game. And for that, we'll dynamically need to change the camera that's being used. So let's also not make this serialized anymore, but just gonna keep this nice and private like that. Now let's drag in our player prefab here. And maybe just gonna go into the game view and try out if things are working. Alright, so to test out if things are working, let's just hit play. And of course we will always need to actually start our host here, otherwise things will not work. Let's just click somewhere, and yes, it's working. So if we click multiple times, we will even spawn, well, multiple characters. But let's of course check whether this actually works in a multiplayer setup. And so for this I got the clone open here, and we just need to reload the scene. Let's just start this one as the host, and the next one we're gonna start as the client. And so now if the host places down a character, we can see it also pops up on the client, and if the client, yes, it also pops up on the host. Perfect. So now both players can actually place objects, and we made a good amount of progress on our AR experience. Okay, so next up we gotta ask ourselves, how do we keep track of each player and whether they have already spawned the character or not? Because right now we can spawn as many characters as we want, but this is not really the purpose of the game. And also in a much more broader sense, just ask ourselves, how do we manage our player data? And this is something we are going to solve now. So let's begin by creating a new folder and call this one player. And then we're going to create a new C# script and we're going to call this player data. Alright, so let's begin by making this actually a struct, as this is only going to hold some data. And of course, a struct is not inheriting from mono behavior, but we need two different interfaces. The first one is I-equatable, like this one. And we're going to pass in player data here. And then from iNetwork serializable. The reason we need to do this is because this struct, this data type, think of it as just a integer or a float on steroids. Basically, is going to be sent over the network, and to send something over the network we need to serialize it, which means we need to convert it into basically a string, you could say so, of characters. And for that we will need these two interfaces, and this red squiggly line is saying us that we need to implement a few methods that are mandatory, because interfaces basically are like a contract, right? So we need to make sure to just implement the method, and here I can just click on its Alt or Start and Enter, and I can implement the missing members like this. And so these both methods need to be implemented in order to make up for the interfaces. So we don't need the start and update method right now, but what we need is to think about what kind of data we actually want to be inside of this struct. So one thing we actually need is this unsigned long, which is going to be, which is going to represent the client ID, of course. So who's owning the player? And then we could potentially keep track of the score. I don't know if we will do this later on, but well, better have it in too early than too late. And then of course, very important, the life points, like this. And finally, we want to also track whether this player has already, well, whether it has already placed its character, like this. Awesome. So then let's also create a constructor for this struct. So a public player data. And here we just gonna take the client ID, of course. We need a score. Same about the life points, and also about whether the player is placed. And then we just simply say this, and then we have the client ID equals to the client ID, and the same thing about the score, going to be the score. And then let's also take the life points, and finally if the player has placed. Oops. Alright, so next up, let's see what we can do with this equals method. So this is basically returning whether given player data is the same as, well, the one saved in this struct. And all we need to do is we need to return, well, whether all the attributes in the struct are the same as the given one. So we can just return whether the other player placed equals to the player placed, and then, oops, and if, well, all the other attributes, so then the life points are the same as the life points in this struct, and if the score is the same one as here, and finally if the client ID is the same one as here. Awesome. Alright, so next up we need to implement the network serialize function, and this function enables this struct to be sent over the network as a serialized string of data. So for that, all we pretty much need to do, it's quite simple. we can take the serializer and we're just going to say serialize value, and we're going to take the reference of the client ID, and pretty much we're going to do the exact same thing with all the other attributes. By the way, I'll put a link in the video description. Not every, so for example, a game object is not something you can easily serialize, and you wouldn't also necessarily need that, because we can just include all the game objects we need in our build. But there are objects that are serializable, for example, standard ints and floats. But there are other objects that are not serializable, at least with the standard way of serializing things. Of course, in theory, you can definitely send over any kind of image or audio file or even prefabs to another player via network. However, this would require a lot more work to do, but still it's definitely possible, just as a heads up. So then let's just fill in these values, so the score, then the life points, and whether the player is placed. Awesome, so this is pretty much all we need for our player data. And now we want to use this player data to actually do something. And for this, we're going to create another script in our player folder, and we can call this all player data manager, let's say. I don't really like the word, like the naming manager, because this could do pretty much everything and nothing. But for our little prototype here, it's going to be fine, and it's pretty much, well, the core logic of all the player data and everything that, well, is around what happens with the player. So I think it's okay. So first of all, let's inherit from the network behavior, as we want to use those methods too. And we also want to make this all player data manager an instance. So we're going to use pretty much the singleton pattern here. So we're going to create a public static all player data manager and call this just instance, or yeah, we can just call this instance, let's say like this. And next up in the awake method, we wanna create a new instance. So we're gonna just say if the instance, well, if this one is not null and the instance is not this, then we want to destroy, because we only want one instance, right? So otherwise everyone who joins would have their own instance, and this would really miss the point of this singleton. And then we're just gonna set the instance to this. Awesome. All right, so next up we need a good place to store all the player data from the players that join, and for that we're going to use a network list like this, and we're going to insert the player data and just call this all player data, let's say, like that. And so it's very important to initialize the network list right here in the awake method, because otherwise we will get an error. So let's simply create a new network list of the player data, and so we can keep track of everything happening. So next up, we're going to use a method of the network behavior, which is called onNetworkSpawn. And this one is going to be called as an event function, just a start and update, let's say. And this is going to be called when the actual network manager starts the network session. And so here we want to just say that if is server. So if this is the case, then we will create a new method in a second, which is called add new client to list. Oops. And we're going to take the network manager and the local client ID. Okay, so the method is pretty straightforward. So we're just gonna call it the add new client to list. And is going to take the ulong, which is going to be the client ID, like that. And we're just going to do a double check here. So if it's not the server, then we're just going to return. And also, if let's say we already had this player onto our network list, then we also, of course, don't want to add it twice. So for that, we can just go through our all player data. I'm going to just call this player data. And if the player data client ID is equal to the client ID, then we're also just gonna return. So then, of course, we want to create a new player data. So call this maybe new player data is a new player data of our struct. And so the new player data client ID is going to be the ID. And the new player data, the new player data score is going to be 0 because it's a new client. And then let's keep on setting the life points. So here we need to decide how many life points each player should have. For that, let's quickly create a constant up here. So let's create a private constant, and since it's going to be integer, as we only have full life points, like this, and let's set it to 10, like that. Of course it's not a float. And let's just pass this one here. And finally, of course, we need to set whether it has been placed. So this one is a false, like this. So now each time a new client joins the server, well, it's going to create this new player data. And of course, we need to add this to our list. But first of all, let's do a final check. So we definitely don't have this already in our list. So we can just say contains. And this is because we actually, in our player data script here, implemented the I-equatable, because now we can check whether, well, actually some kind of player data object is already contained here in our list. So if it contains our new player data, well, then of course we don't want to do anything. We're just gonna return. And otherwise we're just gonna add it to, our list. Like that. Okay, so how do we actually find out whether this method is working? Let's create a little debug method, and let's call this print all player list, let's say. And so all this method is gonna do, it's gonna for each player data in all player data, like this, it's gonna just log player ID, and we're just going to take the player data client ID. We're just going to say has placed, like this, and we're going to print the player data has player placed. And we're just going to call this method anytime we have added a new player. Cool. And one more thing we can add is maybe called by, because this is also interesting who's going to call this method. And so we're going to take the network manager, and then we're going to take the instance or the singleton, and we're going to call the local client ID. So the only thing left to do now is to actually subscribe to whether a new client joins, because this method here, it's only going to work for the server itself, because in our example we have the server and the host. They are just one person, and usually you wouldn't have the server as a client basically in a server authoritative game. So what we still need to do now in our start method, let's just pull this over here, is we need to go into the network manager, into the singleton, and we're gonna say on client connected. And we're going to subscribe to the add new client to list, like this. And now we have in our network spawn method the host being added as a player, and then any other player who's joining later on is going to be added as well. So let's test this out in Unity. So let's first of all start as a host. And yes, we can see player ID 0, which is the host, has placed false called by 0. Awesome. And on the client, let's start the client, and we can see the player ID 0 has placed false called by 0, player ID 1 has placed false called by 0. Perfect. So now it seems like the server is adding a new player data to the network list each time someone is joining. And now we can actually work with that and check whether the player has already placed, or we can also later on just administrate all the data, like for example the life points or the score. Okay, so then let's first of all create a new method which is going to allow each client to set itself as has placed. So we're gonna call this, make it a public void, and gonna call this add placed player. And of course we need then the ID of the caller, and we're gonna just go through basically the whole list by saying for int I equals 0, I is smaller than the all player data count. By the way, we don't use a for each loop and iterate through each of the structs for a very simple reason. You cannot change structs while you're iterating through the actual elements, which means that we need to use just a normal for loop and rather iterate with, well, the count and the I integer. So we're gonna just say that if, well, all player data and at the position I, if the client ID equals the caller ID, we are going to create, and because structs are value based, so they need to be destroyed and then recreated each time we want to make a change. So we're going to create a new player data like this. And what we want to do here is we want to just pretty much keep all the settings, all the info as it is. So we're just going to say we're going to take the existing client ID, we're going to take the existing score, we're going to take the existing life points like this, but we want to set the placed as true, like that. And so next up, we need to go into our place character script and pretty much need to call this. And it's going to be quite easy as we made this an instance, and we can call this all player data manager from, well, any kind of other script. All right, so back in our place character script, we're going to scroll down to the spawn player server RPC. And as this is already running on the server, we can very easily just call our instance here. So we're just going to go on the all player data manager. We're going to just call the instance, and we're going to say add placed player, and we're going to just take the caller ID like that. And so next up, we need to go back to all player data manager, because now we need to find a way to check whether this player has already placed a character down. And if yes, we don't want to allow this player to place any more characters. So for that, we'll simply do a get method. So let's call this public void get has player placed. And we also want to pass in the ID. And we're gonna take a very similar structure to this method. So we're just gonna iterate through each player. And well, if the ID that has passed in here equals one ID on our list, then we wanna return whether the player data on I has been, so if it's basically has been placed like this. And of course we need to define the return type to a bool, like that. So, and then down here we're just gonna return false, like that. And finally, for the add place player method, we need to go into the all player data, and then we want to replace the struct at this position with our new data, like this. Awesome. So in our place character script, now instead of asking for is placed, we're just gonna go to the all player data manager. We're gonna call the get has player placed, and we want to call the network manager singleton and local client ID, like this. And we can also just delete this bool up here because we will not need it any longer. And we can also delete this. So one more thing we might want to do is that if we just start out the game, maybe the instance, so the singleton has not been created yet. So that might give us a null reference exception. So let's just simply check whether the instance is not equal to default, which is kind of like checking if it's null. And after that, we can just check if, if the player has placed already. Okay, so now we can see the player has placed once, and if I click, well, it's not working anymore. That's just the way we want it to be. And if now we're gonna join as a client, let's see what happens. Okay, start client like this. We can see the player. We can also place our object, but yep, not possible. So now we have only 2 characters in our scene, and it's not possible to place any character anymore. And we can also basically see here, this one is only calling when the client joins. That's why it only shows for the server that it already has placed. But yes, indeed, this kind of approach is actually working. Cool. All right, so next up, we want to do the character controls and the character movement. And for that, we'll of course need some kind of UI input. And for that, we're going to install the joystick pack, which is just a free pack in the Unity asset stores. So the link is in the video description, and you guys can just click on it and add it to your assets. So once this has finished, we can go back to our Unity project and open up our package manager. And then we can just search the asset here in our packages. And once you found it, just click on import and import it into your project. Awesome. So in our UI up here, we can just right click and create a new canvas. And we're going to call this player controls. And now before we do anything, just quickly tap on the UI, and we just want to change a few settings over here. So we want to, instead of the constant pixel size, we want to scale with screen size. And our reference resolution is what we have right here. So this is currently, I'm using basically the iPhone 11 as a reference. So we're just going to enter the resolution, which is 1792 by 828 in this case, and we want to match width or height, and we also want to set the match to 0.5. Awesome. So now in the player controls canvas, we can begin adding our buttons, and for that let's go into the joystick pack, open the prefabs folder, and we want to add a fixed joystick, which is not moving, basically, and add this to our player controls, like this. And it's currently white, which makes it a bit hard to see. So let's also change the material of the plane, so we can just see a little bit better what's going on. So let's go to the materials. I think there's just a default material, so let's make a new one by clicking on assets, create a folder, call this materials, like this, and then just create some kind of basic material. Let's call this plain material, and let's make it just a bit grayish. And we can simply, in our scene view, Oops, in our scene view, we can simply drag it onto the plane like this. And let's see, yep, that's a lot better. We can definitely see what's going on here. So next to the joystick, we will also need a button for shooting. So for that, let's simply create a new button here. And we also want to import the TextMesh Pro Essentials here, as we're using, well, the TextMesh Pro package for that. We could also import the examples and extras. We might need that later on, so let's just do it. Great, so then let's change the button's dimensions to, let's say, 150 times 150. So this is going to be our shoot button. We also just want to remove the text, we don't need that. And let's just align it in the bottom right, like this. And we can set our values to something like -150 and, for example, 225. So it's about the same height as our joystick here. Maybe this one we can move a bit down like that. Yeah, looks good. Let's also call this shoot button. Perfect. And maybe we can just change the source image. Let's take a look. Yeah, so we can just take the all axis plane like this, so it looks more like an actual button. And now we have our movement joystick here as well as the shoot button. And now we can add functionality to that. So within the fixed joystick, let's just click on the handle real quick. And we want to add a script which is built into Unity, and it's called on-screen stick. And this is just a way to map the handle the joystick's movement to a certain control path, and so we can later on just transmit that to our character and make it move forward, backward, or whatever we want. So let's quickly test out what happens now if we click play. Okay, so if we move the handle here, we can move it to a certain degree, but it's, well, the range is not enough, I guess, so we need to change this a little bit. So let's unplay here and just set the movement range to 100 and test it again. So let's see. And yeah, this is a lot better, so I think this is enough actually for controlling our character. And next up, we want to set up our control path. So basically, if we click here, we can see, well, different path, gamepad, joystick, mouse, whatever. And this is what we can use later on in our input action maps using the new input system. Or yeah, it's not so new anymore, but the latest input system, let's say, from Unity, to then read those values and make the character move. All right, so let's choose gamepad here. And we want to map this to the left stick. And relative position with static origin will be fine, I guess. So let's just try this out. And then for the shoot button, we will also need something similar. So let's just add the component on-screen button. And here we are going to also take the gamepad, and we can just take, for example, the right let's take the right trigger button, because this is what you would usually use to shoot. It actually doesn't matter that much. We can map those buttons to, we can map any of those control paths to our character, but it just should logically make some kind of sense. I mean, we're also not planning to release this build to, you know, some kind of console or anything, but for now this will be fine, I guess. And we will also actually need an on-screen stick on our shoot button, because well, we are going to allow the player to shoot upwards or downwards a bit. And this is because, well, first and foremost, it can be also a fun gameplay mechanic, but also we might have the issue in AR, I'm going to talk a bit later about that too, that when we do a shared AR session, the meshing might not be 100% similar or identical on both devices, which might mean that one character is a bit higher than the other character. And if that's the case, well, it might not be possible anymore to shoot our opponent, which would be quite unfortunate. So we have to account for that inconsistencies, which are just normal in our gameplay mechanics. And this is definitely a very important point of the initial game design. So we should always design our game in a way where we can just account for potential issues or inconsistencies that just arise with those technical limitations. For example, a different depth estimation in between two or even more devices. So for the on-screen stick, we're gonna just choose on the gamepad, let's choose the right stick. And the movement range, maybe we don't need 50, but we can reduce it a bit to 30. Let's just test it out. And yeah, so it's moving in all directions, but we're just gonna read out the Y value. But I think that's enough actually, and will be fine for our prototype. Next up, let's care about the input action. And for that, we want to create a new input action map. The way we are going to do this is, first of all, let's create a new folder and let's call this input actions, like this. Then we want to right click and we want to create, and we can just select the input actions here. Let's call this player controls input action. And let's just double click this one. So next up, let's create a new action map. And let's also just call this player controls map. And as a new action, let's begin by move. Let's first of all change the action type to value. Control type is going to be vector2. And then let's just simply right click and add up, down, left, right composite. Like that. Then let's set this binding here to the gamepad. And we're gonna take the left stick, the same thing that we chose, well, for our actual joystick here. And to make our in-editor testing easier, let's just change these up, down, left, right bindings here to, well, the WASD keys on our keyboard. So can simply go here and I'm gonna go outside of the gamepad and we're gonna just click W. And for down, we can also just do the same thing. So as for down, then for left, just click A keyboard, and for right press just D keyboard, like this. Awesome, so we have this, and let's just begin by saving the asset. So next up, we're gonna add our shooting mechanics. So let's just create a new action. So let's call this shoot, and it's going to be a button. And we have, well, we chose on our gamepad, it was the right trigger button. So let's just search this one, right trigger, like that. Okay, let's just select it. Awesome. And then we will need to add also the shooting angle. So let's call this shoot angle. And this is going to be the on-screen stick that we also added here to our button, which will determine basically the height or the angle that we are going to shoot with. So let's just choose the right stick, and for that we'll need to change the action type, of course, to value. Well, as it's not just a button that you can click or release. Of course, we also need to change the control type to vector2. And so now in our bindings, we should be able to select the right stick. And so this is going to be responsible then for our shooting angle. Awesome. So let's again save our asset. Don't forget this one. And also here on the right side, if we click actually the player controls input action, we need to generate a C# class and just click apply. Alright, so next up in our player folder, let's just create a new script and call this player input controls. And here we're going to make use of our input action map. So let's just do that next. So first and foremost, let's just get a reference to our input map. So, well, let's just create a new player controls input action here. I'm just gonna call it player controls input action, like that. And well, we also of course need to inherit from network behavior, not from mono behavior anymore. And then we can just override the method on network spawn. And the reason why we need to do this is, of course, we have 2 characters in our scene or even more. And so we need some way to define which are we going to, well, control. And so what we need to do is, of course, we need to find the owner of the respective object. And we can do this because in our place character script, well, we spawned with ownership, which means that we will only own 1 character in each scene. So then what we need to do in the onNetwork spawn function is we need to say, okay, if we want to get the component of type network object, which is going to be attached to our character, and we want to say that if we are the owner, so if is owner, if this is true, so if we're the owner of this respective character, then we want to begin to subscribe to our input actions and actually move the character that we own. So let's go ahead and take the player controls input action and create a new instance of this one. And let's also enable it shortly after. Then next up, we can begin to subscribe to the different actions we just created. So we can simply go into our player controls input actions. Then we can go into the player controls map. And then we will see move, shoot, and shoot angle. So let's begin by moving. And then if we perform moving, we can create a new method. So let's just call this onMovePerformed, like this. And then we want to just read the value of our context here. Let's just quickly rename this as context. So what we want to do is we're going to take a new vector2 because, well, the stick goes up and down, which is equivalent of a vector2. Let's call this v2 movement, for example. And let's just set this to the context. And we're going to say read value. And then we're going to read vector2. So this is going to basically read how far up or left or right we moved our stick. And let's create a new variable up here. We're going to make this a vector3 because we need to somehow translate the joystick movement, which is up, down, left, right, to the actual character movement, which is forward, backward, left, and right. Correct? So let's just create this movement vector like this. And we're gonna then down here set the movement vector as a new vector3. And this is going to have the v2 movement x coordinate. Then for the y there's none because we don't want to go upwards. And then for the z we're going to take the v2 movement y. And so next up, we just want to send this movement vector somewhere where it can be used to actually make the character move. But we're going to do this in another script. So let's create an event up here. So let's make this a public event action of vector3, like this. Just import the dependency here. And let's call this on move input, like that. And we're just gonna say in our update method, if the movement vector is not equal to vector 3.0. So if it's not 0, 0, 0, we're just gonna take the on move input and we're just gonna invoke this one with our movement vector. And so any other script or method in the future can subscribe to this event and just read out the value that we basically calculated as a movement vector. So there's one more thing we can do right now. We can actually create an event and subscribe to it when the move action is cancelled. And this will be very handy later on if we want to, for example, set some animations for the character. So let's set the player controls input action. Let's go into the same map and let's say on move was cancelled. And now we can actually create a new method here that will simply invoke an event. So let's call this, for example, on move cancelled. And we want to just rename this to context, like this. And what we want to do here is we want to set the movement vector to vector 3.0. And we will also invoke an event, which we're going to call, we simply can call this on move action cancelled, like this. And we can simply invoke this one here, and I'm going to show you later on what we are going to do with it. By the way, I think we should actually rename this method. Let's just rather call this one move action cancelled, because this on something is usually used for events. So I think this might be a bit confusing here. So let's just call this move action performed, move action cancelled. And here we have the on name scheme, which is going to make it just a little easier to differentiate. So let's also delete the start method. We're not going to need it right now. And one thing we will also need to do is to unsubscribe from the events. So we also need to override the on network despawn method. And we're just going to take all the events that, well, we have here. We'll also say, well, if we are actually the owner, so if we've already subscribed basically, then we also want to unsubscribe, like that. So before we're going to do the shooting action, let's just make movement work. And for that, let's just create another script in our player folder here. And we're just gonna call this one player movement. So then in our player movement script, let's also inherit from network behavior. And next up, we also will just override the network spawn method. And we're gonna do the same thing basically as in our player input control. So if the get component network object, well, if we are the owner of it, then we want to get our player control input. So let's first of all get a reference to that. So we'll need a reference to the player input controls, like this. And we can just simply copy this one and just say get component player input controls. Now to make sure that we actually have this attached to our object, we could also simply say up here require component type of, and then we can say player input controls. So we make sure that we'll actually have this component attached here. If we want to attach player movement, we'll also need the player input controls. And so next up, we will subscribe to our movement method. So we can just go into player input controls, and we're going to say on move input. We're just going to create a new method. And I think we can leave it at this. And so the general movement is quite simple. We first of all want to just define a movement speed. So we can just say private const float, as we're not going to change this. In our prototype, if you want to just change the movement speed within game, you're not going to make this a constant, but for now it's fine. So it's called move speed, and maybe set it to 0.5, something like this. And all we'll need to do here is we're just going to say transform.position plus equals, and we're going to say, let's call this not obj, but for example, input movement. Let's say input movement multiplied by the move speed. And what we can do too is we can try to not move when there's just a very minor input movement. So if, for example, the player just accidentally touches the joystick, then we don't want a movement to happen. So let's also quickly create another constant here. And we're just gonna call this something like move threshold. So move threshold. And maybe let's just change this one to 0.01f, for example. So we'll need to tweak these values a bit later, but for now let's just say that, well, if the input movement, if the magnitude, well, if this is smaller than our move threshold, we're just gonna return because we might just accidentally hit the joystick, for example. So let's just test out if this is working. So let's click on our player prefab and let's attach both of our new scripts here. So we need the player input controls like that and the player movement like this. And now if we move the joystick, yep, it's working. Oops. So yeah, the character is moving. It's too fast, definitely, but overall it's working. And if we'll test this in our multiplayer setup, let's quickly try this. Oh, yep, and it's also working. So, well, doing fine. One thing we can do to improve our play movement is to have the player look into the direction that he's actually going towards. And so for that, we're gonna define a look at point. So we will need, first of all, a constant float that we just call look at point delta, for example, to f, so that it's 2 units in front of the player. And we're also gonna define a game object that we'll just call look at point, like this. So then in our onNetworkSpawn method, it's gonna make the look at point as a new game object, like this. And we're gonna start by defining its position as the current transform position of the player and also the rotation as, as the transform rotation of the player. And so let's create a new method that we're just gonna call player look in movement direction, like this. And we're gonna take a vector 3 as an input vector, like this. And the point to look at is going to be the transform position, plus we're going to take the input vector, so wherever the player wants to go, and we're going to normalize it, and we're going to multiply it by the look at point delta. Sorry, the look at point delta, like this. And so then we can say for the game object look at point that its transform position should be the point to look at. So it's going to be a bit in front of the player. And now finally, we want to say that the player should look at the look at point transform, like this. And so now anytime we're gonna make the player move, we also wanna make it look towards the input movement, like this. Cool. So of course we'll also need to unsubscribe here from our events. So let's just quickly do that. Just remove all of this and just gonna unsubscribe, and we're gonna call this on, we're gonna override on network despawn. Oops. So like this. Super. And so now if we move around, we should see, yep, it's very fast, but can see that, well, we're actually looking at the position that we're moving towards. Awesome. So let's just also quickly reduce the movement speed. So let's just set it, for example, to 2.12, and let's just check if this is better. And yep, that seems to be a lot better. So I think we can work with that. And as we've also been implementing the WASD movement, we can test this one too. And yes, this is working just for testing purposes to make it a bit easier. So we can, for example, move while clicking shoot later on and see what actually happens. Next thing we're going to do is add animation to our character. And for that, we will first of all begin with a new animation controller. So for that, all we want to do is create a new folder, call it animation. And then we can simply right click, create, and we're going to select the animator controller and call this simple player animator, let's say. And we can double click it, and yeah, so this is just a empty animator. And what we want to do is we want to add 3 states. So those are going to be bools, and we will have is running, and we want to have is idle, and also is shooting, like that. And so let's create 3 states here, exactly for those options. So the first state I'm gonna call again is running. The next one is going to be is idle. And finally, we're going to do is shooting, like that. And so the default state is going to be the is idle one. So let's right click and set it as a default state. So basically on the entry, we're gonna start with the idle, and then from any state, so we're going to make it quite easy, from any state we'll be able to switch in between those states, like that. And so then let's make a condition for each transition. So the condition here would be that is idle is true. Here it would be that is shooting is true. And here it would be that is running is true. Awesome. So now we need to write a script that will, based on our input, handle each animation. And the way that it will work is it will set one bool to true and the other ones to false. And yep, then we can begin creating our animation. So the last thing we need to do here for our animations is, of course, to actually put some kind of motion into our state. So for that, we need to click on this button here, and then let's just make that very small, and we want to search for idle. So we got idle normal, like that. I think that the character here has this pistol, so I think this is HG1. So if we click on is idle, and then we double click actually after we've set the motion, we double click on it, We can also preview the animation, and I think, yeah, this is the one with the weapon, and the weapon would be here in this hand most likely. So then for our shooting, we also of course gonna just enter something like shoot. So gonna shoot auto shoot a handgun, as we not wanna do single shots, but we rather wanna also be able to shoot automatically like that. And again, double click so we can actually see what this animation looks like. Yeah, looks nice. And finally, for the is running, we want to also search for something like run. And here we got run. This is backward, I guess, so this is forward, and have the handgun animated like this. So let's again double click. Let's see. Yeah, okay, looks great. Alright, so in our scripts folder, under our player folder, let's create a new C# script, and we want to call this player animation. Let's open this in our code editor. And first of all, let's create a reference to our animator, and let's call this player animator like that. And we will also need a reference, of course, to our inputs. So these are the, what did we call them? Player input controls. Like that. So player input controls. And I think my code editor wants me to write instances like this. So let's give him this pleasure. And we also will need a list of all the parameters in the animator, which where is idle, is running, and so on. And we're going to store those in an array. So we're going to call this animator controller parameter, and we want to make this an array and call this all params like this. Awesome. So then, of course, as always, we want to make this inherit from network behavior. And of course, we do this because we only want to trigger those animations on the owner of the object. And so let's delete the start function here. I think we won't need it. And let's again override our onNetwork spawn function. And here, as always, we are going to get the component of the network object, and we want to just check if, well, we're the owner of the object. And then we need to, first of all, grab the animator in the children. So if we're going to take a look at our project here, then open the player. Can see that the animator is actually one layer below, so it's not in our player one, but in basically the visual that we have here, and that's why we need to get it in the children's. So we want to say get component and children, and we want to take the animator component, and of course we want to set this sorry, we need to do it like this. All right. And the same thing we're going to do with the player input controls. So we're also gonna get component, but this time not in children, of the player input controls. And then for all parameters, we can simply go into our player animator. We can say parameters, like this, so we have them all stored in our array. Okay, so before we continue here, let's first of all go back into our player input controls, because here we have been only listening to our move input action, and we also want to now listen to our shoot input action. So let's go into our player controls input action, the player controls map. Gonna go to shoot and then on performed, and so we're gonna create a new method and call it, shoot on performed. This is fine. And here we simply will invoke a new event action. So let's create this one here. So public event action. Let's call this on player or on shoot action or on shoot input. Let's say like that. And we're just gonna invoke this one here like this. And of course, we also want to know when we want to stop shooting. So let's go into a player controls input action, player controls map. Then we're going to shoot and cancelled. So when this action is cancelled, create a new method like this. And we also want to create another event for this. And we're going to call it on shoot input cancelled. Like this. And we're going to invoke it as before. Of course, we also want to unsubscribe from that two methods here. So let's just copy and paste it down below. And just gonna put the minus here so we can unsubscribe. Cool. So then let's go back to our player animation script. Now back in our player animation, we can subscribe to all of those events by going into our player input controls. And we're gonna just search for those events. So I think it was like some kind of movement on move input like this. Gonna create a new method. Then we have on move cancelled. Right, then we have on shoot input like this. Create a new method. And of course, we're also gonna cancel shoot. So on shoot input cancelled like this. Cool. So all we need to do now is to, on each of these inputs, actually play some kind of animation. All right, and to achieve that, we can make a new method that we're gonna call set one parameter to true. So let's create set one parameter to true. And it's gonna iterate through, so it's gonna take a string of the param that we want to set to true. It's gonna iterate through all of our animator controller parameters. It's gonna set the one that we want to true, and the other ones are being set to false. So this is a way to very easily manage animation states. Of course, if you would have a more complex animator, you could rather work with a enum and a dictionary like that, because string comparisons can always lead to errors. But for a little prototype here, again, as we only have 3 animation states, basically, it's going to be not that hard. So again, we're going to go for each. So we're going to go through all params. So for each parameter, let's say, so if the parameter, oh, there's a typo here. So if the parameter dot name, if that one equals to our param, then we want to go into the player animator and we want to set bool. And then we're going to take the parameter dot name hash, and we're going to set this one to true. So this is going to be then probably animation trigger 1 or so. And otherwise, we want to do the same thing, but set this one to false. All right, so the only thing we really need to do now is to go to all these methods, and on the shoot input, for example, we want to set is shooting to true. Then on the move input, we want to set, well, is moving or is running. I think it was is running. So we have to be very precise here, to true. And then on any kind of canceling, we're gonna set is idle to true, like this. And of course, when we start out, the default state is going to be idle, so we don't have to care about this in our method. And as always, we need to make sure to unsubscribe to all those events. So on network despawn, gonna take all of those. Well, again, if we are the owner, because otherwise we haven't subscribed. So if we are the owner, then we're going to unsubscribe from all of these events. Like this. Yep, awesome. Okay, cool. So let's also delete this one. So one more thing we might want to do here is we want to check if, so we got this context, right, still here from the vector3 that we are subscribing to. One more thing we can do is we can check whether this context dot magnitude, so the overall kind of power, let's say, if this is bigger than 0, because if we have vector3.0, we don't want to set this one to running. Awesome, so let's take a look if this works within Unity. So of course what we need to do is to actually attach the animator to our player. So let's double click on the prefab, and instead of the pistol animator here, we're going to take our simple player animator. And in our actual player, we of course need to also attach our script. So the animator player animation script, like that. So now we have the input controls, the movement and the animation in separate scripts, which is really nice. And now if we place the character and move around, we can see it switching between running and standing. And if we click on the shoot button, we can see it shoots and it also stops shooting. However, now if we would start our client in our second Unity window, we would see that the animation does not get transmitted or replicated, vice versa. Because what we actually need to do is we're gonna need to attach another component to our player that I'm gonna show you right now. So the component that I'm talking of is the network animator, and this will actually replicate animations throughout the network. But as many components in the netcode for game objects, we do actually have a default server authoritative mode. But we actually need to disable this by overriding, and it's very similar to the actual replication of the transform. So what we simply need to do is, let's just copy this one here, like that. Then let's go back to Unity, and in our player folder, let's create a new script, and let's call this one client network animator, like this. Double click. So then let's make this inherit from our network animator. And we can simply just paste the code here and can very easily use it now. Let's click on our player. Let's go to our visual here with the animator, and let's add a client network animator. And we're just gonna drag in the animator here. And now let's test out whether this also works in multiplayer. And if we take a look, yes, animation is working too. Also shooting animation, awesome. So let's also try it here. Yep, working. And shooting animation working too. Awesome, so we now got animation working in our app. Now let's finally start with the shooting mechanics. And for that we need to create a new prefab that is going to be our bullet that we're going to shoot. For that, simply let's click in our game view here, create a new 3D object and make a capsule. Let's make it, so let's first of all reset the transform. Let's go into a scene view here, and let's also make it very small. Or maybe let's make it a bit bigger so we can see it better. And in the end, we can reduce the size if we want even further, but let's do something like 0.05. And now let's create a new material here. We already have a materials folder, which is here. And then we can just go ahead and create a new material, call this bullet material, like this. And then just set the color to something that you can see quite well. So for example, like this glowing green here. And let's assign this to our capsule. Cool. So next up, the capsule already has a collider, but it still needs a rigid body. And let's first of all make this kinematic, so it will not be affected by gravity. And then next up, let's also not forget to add our bullet. So let's first of all name it to bullet. And then let's prefab it. Let's just create a new folder with just generally prefabs. And then we're just gonna drag it in here like that. And we need to go into our network prefab list and just add the bullet like this. We actually forgot something. We of course need to add a network object to the bullet, otherwise it will not work. And of course we need to add a client network transform to that. And we can also add a network rigid body. Perfect. Okay, so now we already have a bullet prefab, but what we'll still need is we need to go into our player and we need to create a position that will then be the position that the player is shooting from. So for that, let's just go here into the character and let's just go all the way, I think, to the spine, and then let's find the hand that holds the pistol. So we got this one here, nice. And so what we can do then is we can create a new empty object and we can call this something like bullet spawn transform, because this is going to be the place where we're going to spawn our bullets from. And let's just make sure that it's somewhere in front of the muzzle here. So like this. Yeah. I think this should be fine so far. And we also want to create a new script. So in our scripts folder, let's already make a new folder and we're going to call this shoot bullets. And then let's create the script that we're going to call shoot bullet transform reference. The reason why we are doing this is because we want to attach it to this object, and then later on we can just say, okay, find me an object of type shoot bullet transform reference in the children. So next up we're going to do the shoot bullets logic, and for that we're just going to create a new C# script, and we want to call this player shoot bullet or bullets, and then just open it in our code editor. And so this one again is going to inherit from network behavior like this. And so let's first of all set up some references and variables up here. First of all, let's as always get a reference to the player input controls, as we're going to subscribe to the methods there. Then let's create a few constants here, which are going to determine the way the bullet will actually fly. So first of all, let's create a bullet delay. And this one is going to be in the very beginning. So let's maybe take 0.2f float. And the reason why we're doing this is because the animation will take a little bit of time to get the pistol in the right position, as we've seen already. And so we don't want to already begin shooting while it's still pointing at the ground. Then we'll also need a shooting delay. Oops. And this is going to be, oops, we haven't given it a data type. So this one maybe we'll also put on 0.2f, so how much time it takes in between each bullet. And then we want also the speed for each bullet. So let's call this one bullet speed. And let's make it maybe 5 for the beginning. Then we will need some kind of const to define the bullet angle. So we will read the vector2 angle, or better said, the y-axis of the vector2 angle of our shooting button, in order to define whether we shoot up or down, for example. So let's call it something like bullet angle amplify. And maybe make this 2.5f. And then we're also gonna take a bullet shoot angle max. So it's not supposed to shoot, maybe 180 degrees up or so, but we're gonna just limit it by 25 degrees. And so then we'll also need a reference to the position where to the transform where the bullet gets spawned. So we're gonna check it as a transform bullet. Let's say bullet spawn transform. And let's finally also, of course, serialize the actual bullet prefab object. So for that, just gonna take a game object, say a bullet prefab, like this. Cool. As always, we're gonna override our onNetwork spawn method. And first of all, we want to go inside of our bullet spawn transform, and we will try to get component in children. And let's quickly see how we named it. It was named shoot bullet transform reference. So let's grab this one and let's get the transform. And so we can basically spawn bullets just at this game object's transform. And again, we want to check whether we are the owner of the network object. So is owner. And if that is the case, we want to subscribe to, well, all the input actions. So we're gonna get our player input controls is equal to get component. And we're gonna take the player input controls like this. And then we can subscribe to all the important events. So on shoot input like this. And we also need the on shoot input cancelled like that. And finally, we will also then need to transfer the value, which is going to stand for the angle that the bullet will shoot. So either upwards or straight or downwards. And for that, let's just quickly go back into our script. So the player input controls. And we need to subscribe to the final action that we created. So it's the shoot angle, and on performed we're going to just plus equal that and create another method. And here we're also gonna create a new event as always. And we call this on shoot angle performed. And it's going to take a vector2 like this. And so now we can say, okay, if the player, for example, if it moved the shooting button up and down, we will wanna just invoke the event. And for that, we're going to just pass our value here. So let's first of all better change this to context. So that just sounds a bit better. So we're going to take the context and we're going to read value vector2. And so anytime this event is being invoked, we can be safe and sure that we want to change the angle of the shooting. Okay, so next up in our player shoot bullet script, we need to, well, write a few methods here. But first of all, let's also create a variable up here for our shoot angle. And this variable is going to be a float, as we will only need the y value. So let's create a private float and call this bullet shoot angle. And down here in our on network spawn, we of course also want to subscribe to the on shoot angle performed and also create a new method here. And so why not begin by implementing this method? So let's first of all create a new angle here. And then we can also call this vector2 as a angle value. And so then we want to check that if our angle value equals to vector2 dot 0, so that means if we just didn't drag it anywhere, the new angle is going to also be 0. But if not, then let's set the new angle to the current bullet shoot angle, and we're gonna add the angle value dot y to it, and we're gonna multiply that by our amplify, so the bullet angle amplify, and in a negative form. And so then we are going to also take the new angle and we're going to clamp it. So we're going to take the mathf clamp, we're going to take our new angle, and we want to say that it should be on the minimum max, if you want so. So on the minimum, we take our bullet shoot angle max on the negative, and we take the bullet shoot angle max on the positive, so it will always stay in between those values. And now finally, we're just going to set the bullet shoot angle to the new angle, new angle, like this. And so now every time our player will shoot, we can very easily just add this angle to the bullet, and it will either fly up or down. So then next up, let's begin with the player input controls on shooting. And maybe the name of this method is not so awesome, so let's just call this start shooting. So this is going to be a lot easier. And for that, we will also create a new coroutine. So let's also get a reference to that up here. And the advantage is that it's much easier to actually stop this coroutine if we have a reference to it. So let's call this just shoot auto coroutine, like this. And what we want to do now in our start shooting is we want to check whether the start or shoot auto coroutine, if this is null. And if so, that means we're not already shooting. Then we're just gonna set this shoot coroutine to start coroutine. And let's call the coroutine shoot coroutine like this. And then let's create the actual function. So enumerator, and let's call this shoot coroutine like that. Cool. So let's also add those brackets here so that it's working. And in a coroutine, we first want to do a yield return wait for seconds statement, which is going to delay when we actually start shooting bullets, as the animation will take a fraction of a second to just be at the point where the player, well, holds their gun straight. So we're gonna just return a new wait for seconds like this, of course. And then we're gonna do while true, which is always dangerous, but we're gonna dare to use it now. And we will call a server RPC, which we're also going to create in a minute. So let's call start shoot bullet server RPC. And we're gonna pass the bullet shoot angle. And we're also gonna just wait for seconds like this, and we're going to take the bullet delay so that we don't have a minigun, and it's also a lot easier on the CPU. Cool. So now we need to write the server RPC, which is going to be the start shoot bullet server RPC. And of course we have to write this so we have to use this to spawn our bullets, because the client can't spawn any network object. So let's use the server RPC flag here. And we'll also need the input parameter as a float, which is going to be the bullet shoot angle. Awesome. So next up, let's begin by creating a quaternion, which is a rotation value. And of course, we'll need to first of all calculate the shoot angle, as it's currently a float. But what we actually want to do is we want to take the bullet transform value that we defined earlier, and we want to calculate a certain rotation that this is going to be rotated by, so that we can actually shoot in a certain direction. So let's create a new quaternion Euler, and we're going to take our shoot angle, bullet shoot angle. We're going to take 0 on the Y and 1 on the Z, because we are still shooting forward. And then we're going to take the bullet spawn transform, and we're going to set its local rotation to the rotation that we just calculated, like here. So then we of course want to create a new game object for our bullet, and we're going to instantiate a new object, so the bullet prefab. And we want to take the bullet spawn transform and the position of that. And finally, we need to again calculate a quaternion based on the look rotation. So we're going to take the bullet spawn transform and going to take the forward value like this. Cool. So then we need to extract the network object of that bullet. So let's call this just bullet network object like that. And we're going to just get the component network object from that bullet. And we're going to take the bullet network object, and we're going to just say spawn. And after that, we want to take the rigid body. So we want to access the rigid body. So let's call this just bullet rigid body like that. And we're going to take the component from the bullet like this. Oops. Like this. And after that, we want to just take the bullet rigid body. We want to add force. And so we're going to take the bullet spawn transform dot forward. We're going to multiply that by our bullet speed. And we're going to take the force mode velocity change. And yeah, I think that should be good for now. We still need to set the server RPC to require ownership to false, as we also want the client to call this method too. So last but not least, we want to also stop shooting. So let's rather call this method here stop shooting, like that. And all we need to do is, well, if our shooting autocoroutine, if this is not equal to null, then, well, we need to, we want to set the bullet shoot angle back to 0, like that. And we also just want to stop our coroutine, which is the shoot autocoroutine. And finally, we also just want to reset it to null so it can be started again. Okay, so there's a little fix that we should do in between to make spawning and shooting bullets work properly. So instead of having the bullet spawn transform in the hand, let's just put it under the pistol and make sure to remove all the rotation that we have here, like this. And so we can see now that actually the global values here, so the X, Y, and Z axis, they are lining up with the actual object, and this is going to make our shooting work properly. Okay, so both players can shoot, and we can also see at the bullets, they will either go up or down. Let's make it a bit more visible here. Let's move the player somewhere like this. And yep, so you can see this little arc that the bullet is flying, so we can shoot up or downwards. And also if we point downwards, the bullet is going a bit further down. And also on the client, let's test. Yep, looks good, shoots up and also shoots down. Awesome, so the bullets are not correctly rotated, but this is something we can also fix later on. But first and foremost, our logic is working and everything seems great. Cool. And as an easy change for the bullet rotation, let's just go into the line where we actually instantiate the bullet and change the look rotation to bullet spawn transform.up. And this is simply because, well, our bullet spawn transform has the z-axis pointing away from the muzzle, whereas the bullet just points straight upwards. And so we just need to do this little trick in order to get the rotation right. Alright, so next up we want to care about actually hitting other players with the bullets, because right now they're just flying, but there's nothing really happening to it. So for that we want to create a new script in the shoot bullets, and we want to call this one BulletData. And as an idea, this script is supposed to sit on every single bullet and then hold certain information about it. Alright, so as always, let's inherit from network behavior like this. So let's create a new method, make it public, and we want to name this method set ownership server RPC, like this. Of course, we need to make this a void, and then we're also gonna, of course, set a flag here for the server RPC, require ownership to false, so anyone can call it. And we're going to take a ulong here, which is going to be the ID. And yeah, that's our method. And what we actually want to do here is we want to set an owner to each and every single bullet, because as you guys know, we spawn them on the server. So initially the server owns any bullet, and this is because the server will do all the rigid body, all the physics calculations, because otherwise if you do all the physics, you can potentially also do physics calculation on any client, but it's getting a bit confusing, and just doing them on the server is a bit easier here in our game, despite we are generally a client authoritative or client-based multiplayer. And for that we're going to actually create a network variable. So let's create a new network variable, and the value is going to be the long, the unsigned long, and we're going to call this owner, and we're going to initialize it in the beginning with some kind of value like 999, but we need to initialize it in the beginning, at least in the awake method, because otherwise we'll get some issue with Unity. And so now in the actual method, we're going to take this owner value. So this is the way we can access the value. So the ulong in this case, or whatever is inside of the network variable. And we can just set it to the ID that we use to call this method. And so in this way we can, well, actually quite easily just set the owner to this variable. And next up, we also want to make it possible to set a bullet active or inactive. So for that, let's also create a public void and just call it set bullet is active, is active server RPC. And then we're going to take a bool, whether it's active, like this. And let's also make this a server RPC, require ownership to false. And then we just want to create another network variable. So let's call this, so let's make this a bool, and let's call this is active self. And we're going to instantiate this by, of course, true, for example, like this. And then if this method is called, we are going to set, well, the value to is active self dot value to is active. And then we're just going to say if is active equals to false, then we're going to get the component of the network object and we're going to despawn it. And we're going to use this, by the way, later on if we have a collision, let's say. So if the bullet collides with another object, then we want it to despawn automatically, and we don't want any player or any other script to handle this. Of course, we could have gone ahead and actually create something like a bullet pool that will not actually spawn and despawn all the elements, but for, well, this would be more efficient, obviously, but for our little prototype here, as we're also not shooting that many bullets, we're going to be fine doing it this way. So let's also get the component of the network object here and just gonna spawn it if the is active is true. So then next up, we also want to be able to deactivate the bullet. So let's just make a public void and call it deactivate self. And the way that this is different from set active is we want to set a delay here. So maybe just also call this deactivate self delay. And let's quickly create a constant up here. So let's make it a const int and call it, for example, let's say max fly time. And let's say something like 3f, so 3 seconds. Oh, 3, it's not a float. And so let's create a new coroutine here that we are just going to call with this method. So enumerator deactivate self delay coroutine. And here we're just gonna say yield return new wait 4 seconds, and we're gonna take the max flight time. And well, after that we can just call our set bullet is active server RPC and say false. And in our deactivate self delay method, we're just gonna call our coroutine by saying start coroutine and like this. And so now, well, so the idea is that if the bullet is being spawned in the beginning, then we're gonna just call the deactivate self delay. And so after 3 seconds, if, well, it didn't hit the player, then, or if maybe something weird happened, I mean, it could just fly somewhere in the infinity when we are actually in augmented reality, then we will just deactivate it after 3 seconds. And so next up, but most importantly, we're actually going to handle the collision. So for that, we're going to take the onCollision enter method, which is a built-in method in Unity. So we're going to begin by saying if is servers, because we only want actually collisions to be handled on the server. Let's quickly rename this to collision, like this. And what we want to do is we want to say if the collision.transform.try get component, and we're going to take a network object like this, call it network object. So if our collider, the object that we are colliding with, has a network object attached to it, so then we want to do another check. So if the collision game object, if the layer is equal to layer mask, and then we say name to layer, and I think we need to, yeah, first of all create this one. So let's quickly do that. We want to create a new layer named player, and we're just gonna check whether we actually hit another player. Alright, so back in Unity, I'm here in the player prefab, and now let's first of all create a collider. So let's just take a box collider and just increase the size a little bit like this. And we just want to make it a bit bigger because for testing purposes, it will be a lot easier if the collider is, well, if it's something like this size, let's say, and we can always make it smaller later on. But again, if we want to just test whether the collision works, it's easier to make it a bit bigger. Well, and then we're also gonna go through the layers. We're gonna add a layer. Let's call this one just player, like this, and just attach it or just select it here in the menu. And while we can also change the children, why not? I mean, it will only work, of course, the collision will only work with the object that actually has the collider attached to it. So let's say you would put this object to layer player, and you would put the collider here, and this would not be a player, then the collision as we'll implement it will not work. So this is important to know. So then let's go back to our code editor and let's take the name, the layer player, like this. Oops. So then if this is the case, then what we want to do is we actually want to create a new tuple, and this is done by just creating these brackets, taking two ulongs, and we are going to take the from, we're going to call it from shooter to hit. So basically who shot it and who got hit. And then we're going to create a new tuple with our owner.value up there, which we set. And then we are going to take the network object that we took up there, value, like this. And we are also going to take the owner client ID. And then we want to invoke an event. So yeah, let's create a new event. So let's make this event action. Oops, just a normal action like this. And it's also going to take two ulongs. Let's call them from and 2. And we're gonna call this on hit player, like this. And we're just going to copy it and invoke it here. So then we can also decide on where to subscribe to it, and we'll have the information on, well, who was hit by this bullet and who shot it. So we can also then go ahead and reduce the health and do all of that stuff. And then of course we want to set bullet server active server RPC to false. So we want to despawn the bullet, and even if it didn't hit anything, if it didn't hit a player, doesn't matter. We also of course want, if the bullet hit something, we want to set it to false. And one more thing we need to do is we need to make the event static actually, and also public, because, well, usually we like to use events, for example, with a singleton pattern, so with an instance. But of course, in this case, if we have a few, maybe hundreds or dozens of bullets, we don't want to create a single instance for all of those bullets. So we're just gonna create a static event so that we can actually subscribe or listen to it in another class very easily. And so back in our all player data manager, let's just scroll down to the start method, and then let's go to the bullet data, and we're just gonna take the on hit player, and we wanna create a new method that we are going to call anytime, well, the bullet hit a player. And so let's begin by saying, well, first of all, if is server, because we only want to do this on the server. Then we also want to say that if the, let's call this IDs. So if the IDs from does not equal the IDs to, so if the player, I mean, we can also potentially, it's a gameplay decision, we could say that the player can shoot itself. So if you would want to would want that then we don't have to do this check. But if not, then, well, we can just figure out that the player didn't shoot itself. That is the case. So then let's create a for loop, and we want to go through, well, all the player data. So I equals 0, I is smaller than all player data count, and then we're gonna say I plus plus, like this. So like that. And then we want to say that if from the all player data element I, well, if the client ID is equal to the IDs.to, so if we got the player that was actually hit by the bullet, then, well, we want to go ahead and first of all figure out the amount of life points to reduce, and we know that we want to reduce it by 1, so let's first of all create a const up here. So let's call this private const int life points to reduce, and let's make this 1. But of course there might be the edge case that one player only has 1 life point left, and he gets hit by multiple bullets before the game actually ends, and we might go to -1, and we want to just prevent that. So we're going to do that check. So life points to reduce. We're going to check whether the selected player dot life points, if those are 0. And if yes, then we just don't want to actually reduce anything anymore, because the game would be over anyways, and otherwise we're going to do our life points to reduce. And so then we create a new player data like that, and just call this new data, and it's equal to new player data, and just for that matter, we're just gonna take all the existing data, so the client ID, and we're also gonna take the score, and we're also gonna take the life points, and we're gonna say minus life points to reduce, and finally we'll also just take the player placed like that. And now we can just well, say that if we want to make the check that if from the new data the life points are, well, let's just say smaller or equal than 0. Of course, we just kind of prevented that from happening, but I'm still a bit paranoid, so let's do this check. And here we will invoke an event, so let's create an event up here. So in this case, let's make this event public. Event action, here we have an instance, so we can just subscribe to that. I'm just going to say on PlayerData, and we also want to say we want to, of course, put that in our action. So we're going to take a ulong, and we don't need those brackets here, of course. And we're just going to say down here, so we're going to invoke this event, and we're going to take the IDs too, like this. Yeah, and so we can also do something when the player is actually dead, and we will then in a bit actually end the game. So by the way, we can of course decide on how many players we want to have in our game, but for this prototype example, we're just going to deal with 2. So on player dead, we will end the game. But if you want to have 3 or 4 players, then of course you would have to check how many players are left or how many players are not yet dead to end the game. But we'll talk about this a bit later on. And then finally, we of course have to set the all player data to the new data like this. Okay, and then we also of course want to break because we don't want to go through the for loop anymore. And one more thing that we want to do to check if this works, just for debugging, we want to just say debug.log, and then we want to say player got hit, and then we want to print out the IDs too, and we want to print out from, so that we have all the info, and we want to take the IDs from, and finally we can say life points left, or maybe rather, let's rather put that in between here. So we can say life points left is the IDs, the new data life points, and just better say something like shot from or shot by, like that. And of course, as you might have seen, we don't want to do this if the ID from is equal to the ID to, but only if they are not equal, so only if the player has not shot itself. And of course, in our game scene, we need to actually attach the script to the bullet. So double click on the prefab and put the BulletData script on our object. And if we start our game and begin shooting, we see 2 things. First of all, yes, it is possible to actually shoot someone, and we'll see, okay, life points left, 9, 8, 7, 6. And also the server shoots, same thing happens. So player got hit, player 1 got hit, 4, 5, 6. But there are two issues. First of all, there's some kind of weird error message about invalid RPC calls. And the other issue is that, well, the bullet does not have any owner, so we haven't set that yet. But we're going to tackle both of these issues now that actually shooting each other will work perfectly. Okay, so first of all, let's tackle the first error message, which was the server RPC error. And this is a very simple one and lays here in the onCollision enter method. So the problem is that, for example, if we hit another player, we're going to deactivate or despawn the bullet, but then the method will still continue and try to do it again, which we don't want. So we simply missed the return statement here, so that if it hit another player, then it will not deactivate twice, but rather will just return here. And so this was going to solve the first error. So the second problem was that, well, the bullet owner was still on 999 as we set in our bullet data here in the beginning. And to solve this issue and to actually have the owner as the person or the player who actually shot the bullet, we need to go into the player shoot a bullet script, and then we'll go here to our start shoot bullet server RPC method, and we'll need to pass in the owner or the client that actually wanted to shoot the bullet. So let's first of all create a new input variable for this method, and let's just call this caller ID, like this, caller ID. But here in our coroutine, we can simply pass in the network manager singleton local client ID. And then in this method, we can go to our bullet object and, for example, just say bullet and then get component, and we want to get the component type bullet data, and then we can set the ownership, which is a server RPC, and we want to set it to the caller ID. Okay, so let's test out whether these two little additions fixed our problems. And so back in the editor, can just start shooting, and yes, we can see player got hit, live points left, and shot by player 1, which is correct. And if we shoot on the server itself, we can also see, okay, player got hit 1, live points left 5, 4, 3, and shot by 0, which is the first player, which is the server. Awesome, so now we can shoot each other and actually, well, reduce the life points. So then we can also see that, well, if the life points are at 0, nothing really happens. And this is what we're going to tackle next. So next up, let's talk about what happens if the player dies, and let's also in this regard talk about the actual UI. So let's create a new UI canvas by simply clicking on a player, right click, UI canvas, and let's just call this health points, or maybe life points. I think we call them life points UI, like that. And we want to change the render mode to world space. And then we just want to reduce the size by a lot. So just let's make this 1 by 1 and make the position just to 0 and 0. So we can actually see it. And now we can just drag it up like that. And so inside of the canvas, we want to create a new text mesh pro, like that. And here too, we need to reduce the size so that it will actually make sense. Let's do it 1 by 1, and font size we're also going to do 1. And then we'll need to drag this a bit to the left and to the right so we can actually fit some kind of number in here. And for the text, let's put in here 999. And yeah, so, well, this should be enough. I think we're not gonna have more than 999 life points in this game, but for example, if you want the player to, well, have more than that, then you would actually need to increase the size. But for this game, we're just gonna go with 10 life points, so 999 is definitely enough as an example on how big of a number could potentially fit in here. Cool. So then we have our life points UI and our text. And next up, we'll need to create a script in order to, well, reflect the actual life points of that player on the one hand, and on the other hand, we want to also make the UI look at the camera so that any given player can just see, well, what's their life points and the life points of their enemy. Okay, and for that, let's go down our project folder and create a new subfolder. And let's call it UI. Let's place this in our player folder. And let's create a new C# script. And let's call it player handle health UI. Like that. And let's open it up in our IDE. Okay, so in this script too, we want to inherit from network behavior. And we want to begin by, of course, creating a reference to our text. So let's create a new serialized field, and that's a tmp underscore text. And just gonna call this health text. And then we also need a reference to the camera, as we want to make this look towards our camera, like this. And then we're gonna begin by overriding the on network spawn method. And let's first of all also delete those two. I think we'll need them later on, but we can just make it a bit more overseeable like this. And so first of all, let's begin in the on network spawn method to go ahead and set the main camera. And we want to just simply take a game object dot find object of type camera, and we need to do this as we will later on be switching between AR and non-AR, well, to then figure out which camera is currently active. And then we also want to go into our all PlayerDataManager, into the instance we create, and then we have this method. Well, we have onPlayerDat here, but we haven't yet defined a method if the health changes. So let's go ahead and do that. So let's create a new, I'm gonna also create the public event action long on player health changed, like this. And we can do this right here. So simply take the on player health changed and invoke this one. And we're going to take the IDs too, like that. All right, so, and what we also will need, and we can already write, is a method to actually get or retrieve the player health. So let's create a public void get player health. And we want to just take the ID as an input. Oops. And we're just gonna go through our list here. So through the all player data. And we just want to say that if, well, the all player data client ID, if this one equals to the ID, then we just want to return the health, well, life points, I guess it is, yeah, life points like this. And of course we need to have a return type. In this case it's, I think it was an integer, but maybe it was a float too. Okay, no worries. And otherwise we're just gonna return default. like that. Okay, cool. So now we have an event that is being invoked if, well, the health changed of any player. And then in our player handle health script, we can then just get the player health of that player and just return it. We could potentially too just invoke this event with the health points that, well, the player has. But I like to do it this way because we can then use this health change event maybe also for other purposes. And also this method can be used more independently, but it's all just a design choice. And I would guess that just invoking the event with as a tuple maybe with the ID and the health points would be perfectly fine as well. So then in the player handle health UI, we can go for the on health changed. You can subscribe to that and create a new method like this. Let's just recall this to ID. And we also, well, want to make this actually a server RPC. So basically something that is only running on the server and being called by, well, a client. And set this to server RPC require ownership false. And the reason why we want to do this is we of course want to change the health UI not only on the server but also on each client. So we need to, well, do this remote procedure calls. So first of all, we want to check that if, and we can say get component. I think we're gonna put this in the child basically of the player, so not directly on the player. So get component and parent. Gonna get the network object, and then we want to get the owner client ID. If this is equal to the ID, well, then we will call another method that we will create in a second. So we're gonna call this one set health text client RPC like this. And it's also gonna take ID, so let's pass that in. And let's create this one here. So we're gonna make the set health text client RPC. Gonna take the ID and also make this one, make this one a client RPC. So it's gonna be called by the server and executed on any client. And here we just want to go into the health text like this, and we want to set it to our all PlayerDataManager instance get player health by the ID. And of course, we'll need to just parse that into a string like this. And of course, in our onNetwork spawn method, we want to set the health once in the beginning. So we want to call the instance on and so on. This method name is really long. And we're going to get the component and parent again of network object. And we're going to take the owner client ID like that. And as always, let's not forget to attach the script. So let's go to the live points UI. And then we're just gonna attach the player handle health UI. And also let's put the text in here. And so let's test it out. So if we shoot, and yep, the numbers go down. And on the other hand, yep, numbers go down too. And again, we got some kind of error, but that's not a problem. We're gonna just figure out what it is and just fix it. So the issues seem to be again related to this section here, and what we're gonna do now is just create an else statement. Just put it in here to be 100% sure that we will not despawn a bullet twice. And so back in the editor, if we shoot each other like this, we can see it goes down 5, 4, and here 2, like that. And yeah, so we can now shoot each other endlessly and can see each other's life points. So this is awesome. Okay, so the only thing left to do now is to make the text look at the camera. So for that, we're going to take the update method, but not this one, this one. And we just want to say that if there is a main camera, so if we found something, well, then we want this health text transform to look at the the main camera dot transform like that. And now we can see that no matter where we move, like this, the text will always point at the camera. Well, it's still mirrored though, so let's very quickly go into our player and fix that. And for that, we can just set the scale value on our text to -1. Let's move it a bit like this, so it's still in the middle. And now we can see it's floating over the player, and we can very well see, well, what's happening here. So next up, we want to handle basically the game states and also the game UI. So we want to care about starting the game, restarting, and quitting, and what happens if a player basically dies after all the life points are gone. So for that, let's go into our UI, and we already got player controls here, and we want to add a new canvas, so UI canvas, and let's name this one to create join start room buttons like this. And let's begin by creating a single button here like this, and let's design it a little bit by giving it a width of maybe 200 and a height of 150 or so, or maybe 100 is better, like this. Let's make the color a bit darker, and let's also make the text, so let's go to the text, and let's make this one white so it looks a little bit better, maybe the font to 28 or so, like this. So then let's just duplicate the button 3 times and give the canvas a vertical layout group like this. So then we want to align the child's, let's say, in the middle center. And we don't want to force expand in height like this, but we want to get it some padding, so about 20. And these are going to be the buttons that we use to start the game. So the first one is going to be the start button. The second one, let's first of all test out this the first one. Yep, perfect. This is going to be the start button. This is going to be the create room button. So let's take this one as create room. And this is going to be the join room button like this. So join room. Awesome. So we got 3 buttons. So we'll also need another canvas, a third one, which is going to be the quit restart game canvas like this. And here we will need 2 more buttons. So let's just simply duplicate one here and put it into this canvas. Let's call it quit and duplicate it and call this one restart. Also the text should then be according quit and restart like this. Well, I think let's actually not align this one in the middle center, but rather lower center. And this one is going to get a vertical layout group 2. This one is going to be in the middle center, and we don't want to expand on the height, but give it about 20 spacing. So these two buttons overlap, but that's not an issue. We're not going to show both Canva at the same time. But we'll need those buttons to be down here, because later on, when we use image tracking to create an AR chat space, well, we will need this room here to just display the image. That will be the image used for colocalization. Okay, so finally, let's create one more canvas, which we are going to call debug. And we are just gonna place one button in there, which we're gonna call kill player. So we'll make it a lot easier for us to just check whether our restart logic works. So this is going to be called kill. And we're gonna place it, so we're gonna press either Alt or Start, and just place it somewhere in the corner. Just adjust the distance a little bit. And yeah, that's it. So then let's create a new folder in our scripts. And let's call this one game. And we want to create a new subfolder that we can call UI. And then we're just going to create a script that we can call game UI manager. And so here we want to first of all create a new reference, of course, to our canvas. So let's first of all, well, take the one with the create game canvas. Let's call it like this. And then we need to do this another 2 times, and we're gonna call those controller canvas, like this. And lastly, we're going to get the restart quit canvas, like that. Perfect. So we now have a reference, and now we're gonna decide on when to show which canvas. And so let's begin in our start method. And of course, the very first thing we want to do on any client, even before they are connected to our network, we want to show the create game canvas. So let's create a method that we want to call show create game canvas. And we don't need any kind of RPC here, as we are going to call this even before the player is connected. And we want to call this in start, so immediately on starting the game. And we want to go to the create game canvas.gameObject.setActive, and we want to set this one to true, while we want to also go to the other canvases, to the controller canvas, to the restart and quit canvas, and we want to set those to false, like this. And so next up, we want to find a way to show the controller canvas, but this will actually only work if we know when the player got connected. So for that, let's first of all actually create a logic for our start and join game buttons. So for that, let's go back to Unity. And in our game folder, let's create a new script, and let's call this one start game non-AR, like this. And again, this one should inherit from network behavior. And we're gonna get a reference to the buttons. So let's first of all get here 2 buttons. So we're gonna say start host and start client. And so, by the way, as we are currently still working on the non-AR scene, we will not necessarily need all 3 buttons, but I'm gonna explain you later how we're actually gonna use them in AR. And so let's delete the update method, and here in our start method, let's take the start host button and let's add a on click, and then we want to add a listener. We want to create just a anonymous function. And we just want to say network manager dot singleton dot start host, like this. So we're going to start the game as a host, what we always did basically manually. And then we also want to take the start client, on click, and add a listener and pretty much do the exact same thing. But instead of the start host, we're going to take the start client method. Cool. And now we have a quite easy way to actually show the controller canvas. We're just going to do it when we connect it, and this is when we have the onNetwork spawn method. So if this method gets executed, this means that, well, we either started as a host or as a client and joined the game. So in this case, we can just simply take those three and paste them. Going to show the controller canvas like that. And now finally we need to, well, find a way to show the restart or quit canvas. And this is also quite easy. This will be, well, when actually one player is dead. And so here in the start method, we can go to our all player data manager, to the instance, and we can say on player dead. So if a player is dead, again, we're here thinking about two players. If, of course, we want to have 3 or 4 players, you wouldn't invoke on player dead in the all player data manager as we did, but you would rather check for how many players are left and how many players are not dead yet. So you would kind of keep track of that, but that just as a side note. So in case the player is dead, we can say if is server. Then we can call a client RPC. So we say player is dead client RPC like this. And then we can, of course, need to add the client RPC flag here. So then we can call this method. So from the server to all the clients. And what we want to do is we want to show the restart quit game canvas. So let's just copy all of this, paste it in here, and now finally we're going to show our last canvas like this. Cool. So then back in the editor, let's just create an empty object. Let's call this game, and we want to add the start game non-AR method to it, as well as let's put the UI under the game object. And let's take the UI and sort it under the game object. And then in the UI, let's add the game UI manager like that. Let's quickly select the create game canvas, the player controls, and the quit restart canvas. And then in the game, let's go to the create canvas and let's take the create room as the start host and the join room as the start client. Again, this button setup here is thought for AR use. So for non-AR, we only need 2 buttons in this case. But again, this is just for in-editor testing, and later on we will make use of all the 3 buttons properly. So if we start our game, we can see that only these 3 buttons are remaining. And if we click now create room, which is the same as start as a host, then we see the player controls. And well, here too, we can join the room. And now if someone places the object like this, then, well, we can move it. And now let's shoot. We haven't implemented our kill method yet, but now if one player dies, then, well, we have a quit and a restart button, and we got some kind of issue here, non-implemented. So this might be, okay, so we haven't deleted that. So let's just do that like this. And so now the general logic is working. Of course, we got some issues. For example, that it seems like the player health is only going down to 1 and not to 0. But I think for a first take, this is pretty good. And now we're going to implement all the other logic. So let's very quickly fix the issue with the UI health. And for that, in our all player data manager, we'll just need to change the way that we'll invoke the on player health changed. We are going to make this a client RPC so that it will actually properly synchronize onto all the clients. So let's create a method, and we will call this, for example, sync reduce player health client RPC, like this. And of course it should take the ulong as the ID, the hit ID, and we need to flag this a client RPC, of course. And so then we're just gonna take this on player health changed, and we're gonna put it in this method and take the hit ID. And then all we need to do is we need to call this method down here. So like this. And we're gonna take the two, so the IDs dot two. So let's quickly try if this works. And yeah, so this seems to be fine. So by the way, I had some more issues in the BulletData with the spawn and despawn, and I added another layer of security here. So I just said that if not get component, so if it can't get the component network object, just return and do not try to despawn anything. So this method seems to be quite error prone, so be aware of that. So maybe if you also get the errors, then well, just use this little extra piece of security here. Okay, so next up we wanna, well, create two new scripts to restart and quit our game. So let's go into our project and then into the game folder under the script folder, and let's create a new C# script, and we want to call this quit game. And let's open it up. Let's also inherit from network behavior here. And the quit logic is going to be quite simple. So let's first of all create a serialized field for our button like this. And let's take the quit game button. And then let's, in our start method, let's subscribe to the quit game button on click. And then we want to add listener. And for the listener, let's first of all create a new method that we're going to call request server to quit game server RPC. Oops. Like that. And let's also add our server RPC flag here and require ownership to be false. And here all we want to do is we want to go into the network manager, into the singleton, and we want to go into the scene manager, and we want to load scene. And now we'll actually need to load another scene that we will need to create, and we need to take the load scene mode single. By the way, the reason why we are doing this, I mean, we could just potentially also just reset all the network variables and just, you know, get the UI back to its default state. But I tried it and it's very error prone, and you have to consider all the things that you're doing. And it's a lot easier actually for this logic to just load another scene, which could be like a loading scene. And then in this loading scene, just immediately reload the game scene again, because then Unity will handle all of these things for you. It might take a fraction of a second longer, but still it's a lot easier for implementation. And that's why I personally want to do this in our project here. And again, so here we're adding a listener, and this is a method that is simply going to execute the request server to quit game server RPC. Man, I really like those long function names. And so let's set as a scene name simply load scene. There's no scene with such a name yet, but we're going to create this. So let's go back into our Unity editor and let's create a new scene in our scenes folder here. So right click, create scene. Call this, well, I copy pasted, just load scene like this. Let's open it up and yeah, save of course. And all we have to do here, let's create a new UI canvas. Let's just create a new raw image here. Let's just take our Alt or Start key and stretch it all over the screen. Oh, that's really bright. Let's make it darker. And simply create a new UI text. And let's say just loading. And also here, just loading like this. Perfect. And now let's create a new empty object and call this loading logic. And we also want to create a new script here and call this one, for example, load game scene like that. So let's open it up. And so then let's delete this method. And in our start method, all we got to do is we will tap into the network manager, because it's not going to be destroyed when loading another scene. It will still be there. We're going to go into the singleton and we're going to do a shutdown. Then let's create a new list of game objects. Let's call those net objects. And so we want to find object of type. Objects, better said, not only one. Network object. Like that. And then we are going to say select. And then we're just going to say obj. And then we want to get from each object the transform.gameObject. And we want to then transform this into a list like this. And then we just want to say for each object in the net objects, for each obj, we want to just say destroy obj, so we will destroy each game object. And finally, we want to destroy, if, well, not already destroyed, find object of type network manager dot transform dot game object. And finally, we want to go into our scene manager and we want to say load scene game scene, or I think it's simply game, like this. And we want to take as a load scene mode single, so that we don't take anything with us into the new scene. Cool. So let's attach the script to our loading logic object here. And then let's go back into our game scene. And on our game object here, we want to put the quit game logic, and we want to just take the quit restart game canvas and we want to drag in the quit button here. So before we test if this is working, let's just make it a lot easier for us. And let's create here in our scripts folder another folder that we want to call debug, like that. And we want to here create a new script and call this kill player. And all we got to do here is create a new serialized field, then take the button, kill player button, like this. And then let's create a new event. So public static event action, and we're gonna take a ulong here, and we're gonna take the on kill player like this. And in our start method, well, let's delete the update method. And in our start method, we're just gonna say that kill player button on click. And then we're gonna add a listener. And here, what we wanna do is just invoke the event. So on kill player, invoke, and then we're gonna go into the network manager, the singleton, and we're just gonna take the local client ID like this. And then back in our all player data manager, in our start method, let's just go into the kill player, on kill player. Let's create a new method here, like this. Kill player on kill player, awesome. And all we gotta do is we wanna call our BulletData on hit player, like this. And so now let's create a new tuple. So a ulong from 2, and it's just going to be a very random one. So we'll just create, say, 555, and then we're going to take the ID here as a second parameter, and we will just pass it in here like this. And so now if we'll just execute this method and listen to it, we should be able to just kill our player by clicking on the, well, on the kill icon. And let's also reduce our life points to, let's say, 4 or something, so we don't have to press so often. It's really exhausting. So then back in editor on our game scene, let's add the kill player script, and let's add the kill button to our field. So then if we click it, we can see we lose health like this, and we have the quit button. And nothing happens because, well, we forgot to put this scene into our build settings. So let's quickly do that. Build settings, and let's add, oops, go back to our build settings, and let's add the load scene like this. So let's test again. And yes, the game is correctly reloading. We don't get an error message. Perfect. So let's try this out with 2 players. Okay, so our kill script is currently only working on the server because we only need it here. So let's test again. And let's quit. And yes, for both players, it restarts. Awesome. All right, so lastly, let's implement the restart logic. So for that, what we want to do is, again, create a new script, and we want to call this restart game, like this. Open it up. And then let's make this a network behavior. And then, of course, let's take the serialized field for our button here. So like this. And it's called restart button. So then we'll need a new event. So let's make this a public static event action. And then let's call this on restart game, like this. And then in our start method, let's add to the restart button, let's add a listener. And again, we want to create, similar to the quit game logic, we want to create a, first of all, a server RPC. So let's call this one restart game server RPC. And let's put the flag here, client, require ownership false. And then we want to create a new client RPC. So let's call this one restart game client RPC, like this one. And all we got to do now in the restart game server RPC is we're going to call the restart game client RPC, and then the restart game client RPC, we're going to call the on restart game event like this. And in our button at listener, of course, we want to just call the, we want to just call the restart game server RPC here. So then in our all player data manager, let's go ahead in the start method and let's subscribe to this one. We want to go into the restart game, and then we're going to say on restart game, and we want to create a new method here. And so in this method, we want to make sure to first of all check whether we are the server. So if not a server, then we're just going to return. So we don't want to do anything. And then we need to find all the objects that we actually want to reset, because right in the reset logic, we do not simply reload the scene, but we want to give the players the ability to just very quickly go on playing. And for that, what we want to do is we want to first of all get a new list of network objects, and let's call this player objects like that. And we want to simply find objects of type, find objects of type like that. And we can simply search, for example, for a player movement script, which is attached to each player. So we know that, well, these players, these are the actual players. And then we can say select, and we can simply say X, doesn't matter. So the object, the object that we got, we then want to go ahead in the transform, and we want to get component, and we want to get the component of network object of the player, and then we just gonna put this one to list. Cool. So then we also want to get all bullets that might be laying around still, even though the possibility is quite low. We also want to clean up those. So let's look for bullet objects like this, and we can say find objects of type. And then we just want to find bullet data, because these are bullets, the bullets. And then we again can say select, and we want to select every object's network object component like this. And we can also simply put this to list, to list like this. Cool. And so then we can easily for each and go through all those lists. So let's say player objects to begin with, and let's call this player obj. And we can simply say player obj.despawn. And yeah, potentially we could just go actually to the BulletData and then use the despawn function, but we can, well, in the same way also simply go now through our bullet objects and say bullet object and just despawn it like that. And then one more thing we need to do is we need to reset our network list. So let's create a new method for that. Reset network list. And we can also call this down here. And in this method, all we need to do is we say for int I equals 0, and then I is smaller than all player data.count. So let's go through all the player data, and we'll simply just reset it by creating a new player data object and call this reset player, and create a new player data. New player data, like that. And we just want to take the existing client ID, so this one we still need. And then we just want to say player plays to false, so that it's still possible, or again possible, to place someone. We want to set the live points to the live points, and we want to set the score. So we haven't really used the score, but still we might want to use it in the future. So let's reset the score to 0, like that. And last but not least, in our for loop, we of course need to then set the data into our list. So let's set the reset player then to replace the current player data. And lastly, we also want to go into our UI manager. So here let's go into our restart game class, and let's say then on restart game, and let's also create a new method here. And we're simply going to do a double RPC. So let's simply say show player controls and then server RPC, like this. And let's do the flag here, and let's already create the show player controls client RPC, so that this one is working too on each client. Brackets are difficult. Okay, we got it. And so then in the show player controls server RPC, what we're going to simply do is we're going to call the client RPC, and the client RPC, we of course shouldn't forget the flag, and we also shouldn't forget to require ownership false. And what we want to do is then take this logic here and just also put it into this method here, and just call this method, well, on the restart game on restart game. Cool. And we shouldn't forget to actually put a client RPC here too, so that everything is working. So back in the editor, we of course need to attach the restart game script to our game object here, and then simply, well, just attach the button like this. And so if we will test this now, then we will get some error messages. And this is because we were quite lazy and we didn't do something that we should definitely always do. And this is to unsubscribe from events. So for example here, well, if we despawn our player, then this means that things might get destroyed, but it also means that, well, these subscriptions here, well, they might still exist, and so we get some weird error messages. And so for that, in each and every script that we have, we need to unsubscribe in on network despawn. So let's go ahead and say on network despawn, and we'll just simply copy and paste and just put a minus here. It's that simple. Same thing in our game UI manager here. So just copy and on network despawn, and then just paste minus. Then in our player shoot bullets 2, let's just copy this one. and then once more in the all player data manager. So just unsubscribe and then we should be good to go. And now if we'll test, then things should be working quite good. So let's better use this one here and restart, and yep, it's working. And again, and let's restart on the client, and yep, seems to be working great. Cool. Alright, so now that we got our game logic working, we can now finally add AR to our scene. And for that, we just want to restructure our whole scene and add the basic components. So first of all, we have here our game, and this one should contain, well, all the objects that are used both in the AR scene as well as the normal scene. So for that we want to have the place player, so we need to place a player. We have the player data. Then we would have the event system. And I think that's about it. So then let's create a new empty object and call this scenery non-AR. And let's put the camera, the light, and the plane in here. And the network manager, we're just gonna call network manager non-AR. So then this button, which button is it? Let's take a look. Not 100% sure here what button we're dealing with. Maybe some kind of random button. I don't know. Let's just delete it. And so we have our network manager non-AR, our scenery non-AR, and now let's create another empty object and call this network manager AR. And here we're also just gonna attach a network manager like this. And this time we're going to, well, for the network transport, we're gonna choose the Lightship netcode transport like this. And of course we can also just add our network prefab list. So then we're going to create another empty object and call this scenery AR. And let's first of all go ahead and just, well, deactivate those two objects here like this. And in the scenery AR, let's go and add a XR origin. Let's add an AR session like this. And let's also add a directional light like that. So under the XR origin, let's create another empty object and call this one meshing, because we're going to use AR meshing. And we're gonna add an AR mesh, or just a meshing. Gonna use the Lightship meshing extension. And it's going to add the AR mesh manager automatically. Let's already then set the settings here. So the concurrent queue size, let's increase that to 50. Target frame rate, maybe 15. Integration distance, 5 is fine. And the rest is all good, I would say. And in the camera, just make sure that the light estimation is enabled. So let's quickly find that. Light estimation, let's set it to everything like this. So now let's also go to our Lightship tab here, go into the settings, and then we want to set a dataset path, and we're going to use some playbacks to test AR in editor. And in the video description, well, you will find some samples that you can download to just test AR with the video feed in your editor. Let's also quickly take a look what's happening here. iOS SDK is enabled. So, well, we'll need to do that. Apparently something didn't work here. And yeah, I don't know why there's this error message, just clear it. And I think we'll be good to go. So now if we're in our game view and we'll hit play, let's just see what happens. And we can see that we have now our video feed here, which is exactly what we want, and the UI is working as before. Cool. So then let's also create a new mesh prefab that we want to use for meshing. So then let's just close some of these windows here. And let's create a new folder. Let's call this AR meshing, like this. And then in our hierarchy, let's create a empty object, call this AR meshing prefab, like this. Then we want to add a mesh filter, then a mesh renderer, and a mesh collider, like that. So then let's drag it into our AR meshing folder. Let's delete it here. And we double click on that, and in the materials render, let's also, in our materials folder here, let's create a new material, call this one meshing material. And what we can do is set the rendering mode to transparent, and then maybe do something like bluish, like this. And we just then want to set the transparency value here, so that you can only you only should maybe slightly see it in your game view, like that, and it should just basically outline or just underline well, the play area. But of course you guys can do it as you wish. I think what would be really cool is to have a material that just outlines the whole mesh, but this is something that you would do with shaders, and would also require some calculation, and this is well, this is another whole tutorial. So let's just go back here and then double click on our AR meshing prefab and use the meshing material and just drag it in here. By the way, we could potentially also just use an invisible material that will only cast shadows, but then it's less clear where the actual, well, the game map is. So for that, let's just leave it like this. And now let's not forget to actually drag the AR meshing prefab into our AR meshing manager. And then if we start the game, yes, we can see that our AR meshing is working. So we could potentially now try to create a room, but this is not working because we haven't created any logic to actually handle the Lightship transport system and the way that AR multiplayer works. But this is what we are going to do now. And let's create a new script in game, and let's call this one start game AR, like this. And let's double click and open it in our code editor. Okay, so now in our script here, let's begin by, as always, deleting those methods here and start clean. And let's create a new serialize field. And this is going to be for the shared space manager, which we're going to add in a bit. And let's just call this shared space manager. Then we want to set a const int for the max amount of clients per room. And for us it's 2, but of course, again, it could very easily be modified to 4 or 5. Basically, the only thing that we would need to check is, well, that we don't end the game unless there's only one player left with life points, and we would have to despawn a player if the life points are empty, right? So it would be quite easy. Then what we need is, as we are working with image tracking, we're going to create a new serialized field and a texture, use a texture 2D. And let's call this one target image, like that. And then there will be also a float for the target image size. And finally, we're gonna take a room name And well, this one could be also modified potentially when there are more people around, but for our testing purposes, we're just gonna keep the room name at test room. But again, if you would wanna go for a production ready game, let's say that's not a prototype, then we would wanna also enable the user to well, choose room name, because based on this name it's gonna be decided whether another player joins or if a second room is being opened, basically. So then let's create our serialized fields for our buttons. So let's create a new and then button. Oops. And let's call this start game button. And we want to just duplicate this one. So copy paste this one. And then there will be the create room button and the join room button. And the logic will be that you either create or join a room based on an image and you then start the game separately. This is going to make it a bit easier because otherwise you might get issues, since creating a room or joining a room is an async method, which means it will not execute in order, but it will execute as it says asynchronously. And so if we just immediately try to start a game once we have created a room, or once we try to create a room, could be very error prone. But this approach will, well, just pretty much cut out this error, as it will not take longer than a second or so to actually create a room. Okay, so then we also want to store whether we are the host or not. And then let's begin by writing some methods. So let's start with the awake method, and let's begin by saying that we don't want to destroy this game object on load in case that we restart, for example. So next up, we want to go into our shared space manager, and we want to find out, so we want to subscribe to an event when the state changed, so the connection or tracking state basically changed, and we want to here create a new method. Create a new method like this. And what we're going to do in this method is that we want to check, so we're going to start our shared space in a bit, and we want to check whether we are actually then successfully tracking a certain image. And only after that we want to, well, enable the client or the one who created the game to start it. So then in our awake method, we want to take our buttons and say on click and add listener. And let's quickly do that and then write the method. So we need the start game button, the create room button, and the join room button, like this. And then we will create three methods. So one will be the start game, like this. The other one will be create game host. And the other one will be join game client. So those methods are going to be quite similar. So let's create game host. Let's create this method. And what we want to do is we want to set is host to true, like that. And then we just want to invoke an event, and let's call this one up here. Let's create a public event action, like this. And we want to call this one on start shared space host. And let's also create another one, which we're gonna call And let's also make it static actually, so we don't have to create an instance like this. And this one is going to be on join shared space client like this. And let's invoke this event here. And in our next method, which is going to be join game client, we're just going to do the exact opposite. So isHost is going to remain false, but let's just for understanding, let's write it like this. And let's also invoke this method here. Cool. So then let's also create the start game method like this. And this one is, well, first of all, if we are the host, then we want to go into our network manager, and then we want to go into the singleton, and we want to start as a host. So as we've already done in our other method, and otherwise we want to go into a singleton and we want to start client like this. And let's also create another event here, so that we're going to use for our UI amongst others later on. Let's call this on start game. And let's also invoke it here in our start game method. So on start game dot invoke like this. So then we're also going to do a bit of UI logic, which, well, you could potentially separate, but again, we're building a little prototype, and for that it's going to be fine. So what we want to do is, so this method is basically, by the way, this method is returning, or this method is calling when we, for example, create a host or join a game client, and actually a shared space has been either created or joined. So for example, based on an image, and then this event is being fired and this method is called, and the tracking means that, well, the image tracking was successful and we actually joined a nearby room with the same name. And then what we want to do is we actually want to take the start game button and make it interactable like this. Send it to true, of course. And the other button, so the create room button, interactable, is going to be false. And the join room button, interactable, is going to be false too, like this. Now then, in our awake method, let's make the start game button not interactable, as we only want this to work, well, we only want to start the game if we have an actual connection, if our tracking is set up so that things are, well, in order and working actually. So then in our create game host method and in our join game client method, so let's call the method that we name start shared space like this. Oops. And the same thing here in our join game client. And then we want to just create this method, so call it start shared space like this. And then let's first of all create another event action here that we're going to fire in a bit. So an event action start shared on start shared space like this. And let's begin by firing this event. And then we first of all want to check the colocalization type. So the shared space manager get colocalization type, And then let's check whether this one is the mock colocalization, because this is the way that we can test shared AR in editor. And if this is the case, then we want to have a new variable that we're going to call, let's say, mock tracking arcs. And this one is going to be of type I shared space tracking options. And we're going to take the mock tracking options like this. And then we want to create the room arcs. And those are going to be of I shared space room options. And we're going to say, and we're going to go into the create lightship room options. Then we want to take our room name. Then the capacity will be 2, or let's take the max amount of clients like this. Description, we can just say mock colocalization demo, for example. And well, that's about it. So then we can just go into our shared space manager and start shared space with our mock tracking arcs and our room arcs like this, and then return. So this is for our mock colocalization. Otherwise, we can say, well, we can pretty much just copy this and then say if it's image tracking colocalization, we're going to do something a little bit different. So we're going to say these are our image tracking options. And then we're just going to say create image tracking options like this. And for that, we'll need the target image that we created a while ago, and then also the image size. So let's put those in here. And then we will also create a room with the room name, the max amount, and let's call this image colocalization as a name. Like this. And then we want to start our shared space with our image tracking options and the room arcs, like that. So then back in the editor, let's add to our scenery AR. Let's add the start game AR script here. And then we'll also want to add the shared space manager like this. And here let's use the mock colocalization. So we can just switch here between different colocalization modes, and we want to switch to mock for the beginning. And then from our game, let's get our start, create, and join buttons. So start, then create, and then join. Like this. Target image size, it's also set at 2.1. The shared space manager, let's just drag in the object again. So the target image texture we are going to set a little later. We just want to check if generally things are working out already. And so now if we hit play, we can see that the start button is grayed out and it will not work. And if we now click on create room and just tap somewhere, and yes, well, it's very big, but there's actually a player being spawned. So let's first of all care about that. Let's take the default female PBR here, and maybe we're just gonna set this one to 0.25 or something. Let's see if this works. Of course, then we'll also need to just change the UI, so let's drag it down, and I think we might even need to just change the width and height here, and then let's reduce the scale like this so that it's very small and somewhat fitting to the size of the character. So let's not forget to also adapt the bullet size. So let's make this 0.01, for example. And let's try out how this is going. So let's create a room here. Let's click. And yeah, the size is a little bit better. However, I think it can be still smaller. So let's do that. So let's set it to 0.125. And the bullets, I think, well, let's see how the dimensions are. And yeah, that looks a lot better. Like that. So yeah. There seems to be some kind of issue though with the collision here. So we always get the bullet has collision to player. Let's see, maybe there's something with our transform that we set. Okay, so there might be the issue that if the bullet spawns here, it will immediately collide with the player. And so let's drag this a bit in front, but first and foremost, let's just check actually the collider. Oh yeah, so that's the issue. The collider is still gigantic. So let's just manually reduce the size so that it will fit. So let's drag this one down like this. And yeah, so that should be a lot better. Let's check. Oh, it's not so much in the middle. So let's reduce, let's set the center to 0, 0, and 0. And then on the y-axis, let's move it a bit up like this. And let's also decrease the Y size here a bit like this. So that it's not on the ground too. And then the size of the X. Let's also reduce this a bit. So yeah, I think this looks quite good. And I would say that probably we don't get this error of collision here. And yeah, so bullets are flying, that's good. But there's something wrong with the UI still. Let's figure out what that's about. So we still need, of course, as we adjusted the size twice, let's just also bring down the UI. And yeah, we're getting really small here, but in AR usually the dimensions are quite small. So that's just the way it is. So yeah, after some testing and trying, it finally works. So next up, let's try multiplayer. Okay, so here in our parasync clone, everything works. Again, sometimes I had the issue that there were some kind of weird errors here, and I just deleted the clone up here in the clones manager and created a new one. That sometimes happens if you really do a lot of changes, but yeah, seems to have been not the case yet. So let's try to create a room here. Let's place a player, and let's try to join a room here. And yep, so well, we're here and things seem to be working out. So yeah, we are here in multiplayer. Cool. So of course this is still, this is of course still in mock mode, which means that if we would build it to our device, nothing would really be working. But generally we can be safe that we have first and foremost implemented the Lightship netcode system correctly, and now we're going to deal with the image tracking. So the way that image tracking works in Lightship currently is that, well, by default you will have to pre-select and pre-import an image that then can be used in shared AR to colocalize, so to find the other client's position. So the way that image tracking colocalization currently works by default for Lightship is that you will have to pre-take an image, import it in Unity, and then set it as a target image so that, well, other players can, for example, scan the same image, and so the colocalization happens. This is, of course, not really convenient, as if we want to actually ship a game, then we would also have to, well, deliver some kind of tracking marker that people would have to print out and then use. So a bit later on, we're going to figure out a way how to dynamically set an image so that players can actually, when downloading the app, set this image inside of the game and then just use it dynamically. But for testing purposes, let's just begin by using a standard image. So something that works really great is book covers. So I took a picture of a book that really deeply frightens me. It's this one here, so you may understand why. And so I'll just take the image and drag it into Unity in the assets. And I'm going to create a new folder, and I call this folder image tracking, like this. And here we're just gonna drag in the picture. So let's click on the picture and then let's go to the top right and open properties. So then let's take this panel and integrate it here. And let's make a few changes so that it will actually work with Lightship. First of all, let's change the texture type to sprite. Then we want to set the read and write to true. And finally, let's set the format to RGB 24-bit. And just apply. So now in the editor, let's just go to our scenery AR and to the inspector. And then let's just drag the image as the target image. Then next up, let's make sure the colocalization type is set to image colocalization. And so now, as we cannot test image tracking colocalization in editor, we'll have to build it to our device. So let's do that next. So let's click on File, Build Settings, and choose the platform and click Build. Okay, so now if we build the app to our phone and try out if it works, so we can actually create a room, this is working, and also join a room, as we can see here. So the thing is that the game is somewhat starting without actually us hitting the start button, and this is due a little mistake that we've been doing in the way that we set up our game manager. And also, well, we can place down the characters and run around and shoot. But there's also a little issue here with the height difference, and this is something we are going to talk about in a bit. But first and foremost, generally things seem to be working, but we also need to do some more adjustments to actually make the game finally work. So one easy fix that we can do is just reduce the move speed. This is way too high, so instead of 0.12, let's set it to 0.04 or 0.03, something like that. And let's test out if this makes a difference. So make sure to switch back to mock colocalization. Let's create a new room, and yeah, the movement is a lot better. I think this is fine. And also then shooting, the shooting speed is quite high. Let's also reduce that by a bit. So for that, let's go into our player shoot bullet script, and let's also reduce this. Instead of 0.25, let's do something like 0.11 or something and take a look on how that is working out. And yeah, this seems to be a bit better. So yeah. So I think we also actually forgot to despawn our bullets if they do not hit anything. And this is especially proud now if we are in AR. So let's go into our bullet data and let's create the on network spawn method. And we're just gonna then call the deactivate self delay, so that will deactivate itself after a certain amount of time if it's still alive or still active. And so to test this in our editor, let's just shoot in a direction where there's no mesh. And here we can see now our bullets, and they will auto despawn after a certain amount of time. And of course, if they just get destroyed, if they just hit something, then they just get destroyed right away. And we made the mistake that in our game object here, we still have the start game non-AR script attached. So let's quickly copy it and then remove it. And we want to add this to our, I think we got this, yeah, to our scenery non-AR. So just add it here like this and paste it. And it will automatically add the network object. So now we shouldn't have the issue that on create or join room, it will immediately start the network. So let's try out again. So now when we click create room, we'll still can click start, and then we can click and actually start it. Yeah, so this is nice. So one more thing we want to do is we just want to start the meshing when actually a room is being created. So for that, let's go into our scenery AR to the meshing, and let's first of all create a new script here. In our scripts folder, let's create a new folder and call this one meshing, like this. And let's call the script start meshing on network spawn. Well, this is exactly what it's going to do. Let's add the script to our meshing game object and then just double click. Let's make this inherit from network behavior, and then we just want to go into the start method, and let's first of all create a reference here to our AR mesh manager. It's gonna call this mesh manager like that. And then in the start method, let's go to the mesh manager and let's say enabled is false. And then we want to say that on network spawn, the mesh manager will be then enabled. So let's set this one to true. And so lastly, let's make sure this one here is serialized so we can drag in our actual mesh manager. And then let's drag in the component and hit play. And as we can see, when starting the game, nothing happens. If we create a room and then start, now meshing is working. Cool, that's the way we want it to be. So now in our grand finale, we want to work on dynamically changing the image that has been used for image colocalization with a render texture. And for that, we're not gonna write the script line by line, but I'm just gonna create a new script and just gonna copy and explain a bit what's happening. Again, you can find all the scripts in the video description. So first of all, let's create a new folder and let's call this folder image blitting. And then we're just gonna create a new C# script and call this blit image for colocalization, like this. Double click, and we're just gonna paste our script here. So take this and just paste like that. And we'll just import a few of those dependencies here. And so this one is actually the start game AR script, and these are the event actions we actually created. So I think it's not, it's on join, not start shared space client, like this. And then let's go down and do the exact same thing here. By the way, I'll upload the already edited script so you can just copy and paste it like that. And then I think there's some kind of bracket missing here. Yeah, okay, perfect. So now things should be working. So we have our blit image for colocalization script, and it will require a render texture. So back in the editor, let's go into the scenery AR and let's create a new UI canvas and just call this one colocalization, like this. And let's create a new raw image here, which is going to basically show the image that we've taken. And let's just set the width to 460 by 240 for the beginning. And then in our project view in the image tracking section, let's create a new render texture. So we want to go to create, and then there is render texture like this, and let's call this blitting image. And then under our scenery AR, let's just quickly add the script we just created. So the blit image for colocalization. And let's just put our render texture in here like this. And then in our raw image, let's also just put the image texture in here like that. Let's also set the render texture to a size of 1792 by 828, and this is depending on, well, what kind of settings you're using here. So I just took over the resolution. And then we're just gonna create another script under the image blitting, and we want to call this show hide blit image UI. So let's open this one up. And let's paste all the code here. And again, I'm just gonna exchange the name of the script like this. Let's also make this a network behavior. Let's go back into our start game AR, and we still have the on start shared space event here. So this one is the on start shared space event, which is going to trigger for both like this. And here in our colocalization UI, let's just drag the script that we just created. And let's drag in the image. Then one more time the image, then the render texture that we have here. And then we're just gonna create also a new button for retaking an image. So for example, if a player just is not satisfied with the image that is set up for colocalization, so let's create the button. Or better, let's rather take a button from the game object. So let's go into the UI and let's take the button here, maybe the start button, let's say. Let's paste this one here and put it into our colocalization UI. Then we can take a vertical layout group like this. And we also gonna say force expand on the width not and on the height neither. And then we're just gonna take it in the middle center, and let's rearrange this here. Let's also not forget to set the UI scale mode to scale with screen size, put it to 0.5, and just enter the current resolution that we're working with like this. Yep, nice. And finally, in our vertical layout group, let's go into the padding and let's add some bottom padding, so we're somewhere up here like this. And let's also add a bit of spacing in between those two buttons. So then let's rename the button into retake picture. And let's change the text to retake picture. And in the UI script, let's actually also add the retake picture button here. And so now if we start the game and click create room, something quite cool happens. Well, we actually see a picture being taken from the camera feed, which can then be used as the image colocalization center point. So the only thing left to do now is to feed this into our AR scenery, into the start game AR script. And if this is done, Actually, we don't need to print out any kind of image anymore. We can simply just use this one as our starting point, and people can just start an AR session, AR shared session without any big hassle. So let's do that. So let's take a look at our Blit image for colocalization script. And all this one is doing is well, first of all, finding our AR camera background, which is attached to our XR origin. And so it's listening to whether we start the shared space as a host or as a client. And once this is done, we wanna it's going to update the render texture size. So this will just check if we are actually holding the phone in portrait mode or in the vertical mode. And after that is going to just take the camera background, so basically our camera image, and it's going then to create a new 2D texture, and it's just gonna copy that into our render texture, and is also firing this onTexture rendered event somewhere down here with the camera texture. And now we can use this again in our start game AR script to set it to our target image. So for that, let's go into our Blit image for colocalization and listen to the onTexture rendered event. And then we can create a new method. So let's leave it like this, Blit image for colocalization on, well, let's just do one on, I think that's enough. Like this. Let's call this texture. And what we want to do in this method is actually quite simple. We will then create a new method that we will call set target image. And we're going to feed in the texture. And then we'll also just start shared space. Like that. And so the set target image method is just going to take a texture 2D as well. Texture 2D, like this. And we're going to very simply set our target image to the texture 2D, like that. And so below here in our create game host and join game client methods, we are not going to simply start shared space already, but we are just invoking the onStart shared space host or client method, and these are being listened to by the by our show height Blit image UI, by our Blit image for colocalization script, like this. It's going to then set the texture, and once the texture is set, it's going to be sent back by this event action, and then it's going to, in our start game AR script back, it's going to then trigger the this function here where we're going to set a target and then start the shared space. So let's see how that is working. So then let's keep an eye on the target image property here on the right side. If we create a room, and yes, we have our image here, and we could potentially start it, and the same way the client can join it. We still though have here our retake picture button, which should enable us to retake a picture when we are not content with it. So let's do this logic. So for that, in our image splitting folder, let's create a new C# script and call this script retake image logic, like that. And here just create a new serialized field like this, and we're going to take the button, so the retake image button, like this. And then all we need to do then is in our start method, we can just listen to the retake image button. On click, we want to add a listener, and let's then create a new function here that we want to call quit game to retake image, because this is what we're gonna do, which will be the easiest way. We're just gonna go into the scene manager and we're just gonna load scene, and we're just gonna take the load scene, and we also wanna load that in single mode like this and just put it in here. So then let's add the script to our scenery AR. So let's drag it in here, and also let's drag the button in here, and then let's try to start the game, and then let's create a room, and let's try to retake the picture. And well, we are loading, but for some reason things are not getting destroyed here. So let's find a way, or let's find the reason why that is the case. And this issue appeared because we have the scenery AR here in our don't destroy unload assets. And of course, this is not getting destroyed. If we quit the scene and then reload it, it's staying there, and then we'll have two AR scenes basically. So let's take care of that. So in our load game scene, we also want to search for an object that holds the start game AR script. So let's do that. Let's create a new game object and call this start game AR object. And let's find object of type start game AR. Let's get the game object like this. And we just want to destroy this object. And now we can click on create a room. Then we can click on retake picture. It's reloading and there is no error message really. Just saying that there are two audio listeners, not 100% sure where. But nevertheless, seems like things are working. Let's try it again. Okay, so we have still some events that we haven't unsubscribed from, but that's not an issue. We can just do that. There's no problem. And yeah, so then I think our logic is working. So this is in our start game AR method. So let's just quickly fix that. But first, let's pause the game. And as this is a mono behavior method, let's take the onDestroy method, and let's just take both of those events and just unsubscribe like this. So then if we retry to create a room, retake the picture, create another room, retake the picture, create another room, retake the picture. Yeah, seems to be working fine so far. Let's create a room and then start a room. Meshing works, we can place a player and just start shooting. Cool. So then let's finally test if this is working on our phones. Okay, so let's try to create a room and to join another room. So this is just a dynamically taken picture. So this one is working no problem. So then also placing is working, and the replication of the position is kind of good. You can see it's not 100% the same position, but it's good. Shooting works. And restarting works, so that's pretty fine. And here we have an interesting case where you can't shoot the other because of the height difference, and so shooting down also works. Alright, so here we have it. Our multiplayer shared AR prototype is finally finished, and I hope that it was, well, kind of useful for you guys. And if you have watched this video to the end, congrats, and please write something in the comments so I can find out who actually watched this video all through until the end. So some more thoughts on this prototype. So first of all, what I would always recommend with any AR app is to always have the option to actually design your game in non-AR, because just trying out the different game modes and just making progress on the actual logic is a lot easier when you are not in AR. So again, for this game, you can simply deactivate those two, activate the non-AR objects, and then just start the game. Of course, well, the start button here is then not working, but other than that, we can simply play the game. And yeah, of course, I mean, the scaling and like the movement speed, maybe we would just need to reduce the movement speed a bit more and then just get the camera a bit closer. But overall, it would be very well possible to just build the game here and then just get the logic working. Again, we can also work with WASD. Again, the speed is way too fast for this. But this is just a great way to design and create your AR games, especially that if you, for example, want to first of all create something that is actually fun to play. And all you got to think about here is, okay, is this something that would also work in AR, right? So do we have a surface, or are we looking at some kind of level design that is going to be enhanced by AR? But still, I think it's a great approach. The other thing is about the meshing. So you've seen that the meshing is done on both devices separately. There is no actual shared AR meshing. And that's why we need to incorporate some kind of game mechanics that will allow us to just even somehow the gameplay experience by, for example, making it possible to fly, to jump, or to shoot up or down, something like that. Since especially on older phones that don't have a LiDAR, let's say, and have also older processor, the meshing will not be as accurate as on the newer phones. Maybe if you have two brand new iPhones with a LiDAR scanner, then the meshing will be 100% the same in regards to its depth and position, but we can never be 100% sure. And also here in our game, we can see that depending on where the players just place their unit, their character, they will not be able to even shoot each other. So maybe we would need to implement some kind of flying mechanics, let's say, or some kind of jumping mechanics or something like that. So to incorporate for these issues. And yeah, so one more thing to consider is that there's also no real measurement of how good or bad the scan is that the player takes, right? So if you scan just a very small object in a bad lighting condition, the colocalization will be quite bad. While if you are outside and it's very bright and you have a very striking object that you scan, especially against something like a painting or a book cover of a bigger book. Those are really good for colocalization, but there's no built-in way, at least as far as I'm concerned, to actually show that to the player how good their scan is. But this is something that, well, either can be done through just giving instructions via a text, for example, or to, well, just write a script that will somehow analyze the quality of the picture. And also one thing to notice is that the bigger the object that is used for image colocalization, the better is the tracking. If we have something like a small object, then the accuracy will not be that high. But if we have something like a book cover, it's going to be a lot better. However, the positioning of the players, relative positioning, will always be the same. So maybe it will not look as identical as it should be on both of the phones, but the actual player position on each phone is going to be relatively the same, which makes no issue for the gameplay mechanics. Alright, but that's it for this tutorial, so thanks a lot for watching. I hope you enjoyed it and see you next time.